Alright, I need to apologise for that because apparently my internet decided to cut everything out for some stupid reason for the first time in about, well, ever since I've moved in, essentially. Ridiculous, absolutely ridiculous. I'm absolutely teeming right now. But we're going to get through it. I'm going to continue. I did stop the timer while I went and tried to sort out everything. So we will continue that absolute ridiculousness. But yeah, so I do apologise about that. It's really weird, just whole internet disconnected. Wi-Fi was fine, just the Ethernet. Just really, really weird. Anyway. Let's continue with this stupid question. So, I don't actually know what I'm doing for this thing. I don't know what the correct method is. I don't know what's to do. Like, they give you these stupid percentage numbers for some reason. Like, how are you meant to work out the mean standard deviation for numbers that like aren't in the 68, 35, 68, 95, and 99.7? Like, so I think, like, height's 175 meters, which is 97.5% bigger than anything else. Which is not that one either. So let me get rid of that one and replace it with, so 97.5 is like in here. Female, 175 centimeters, 160.6. %, 97.5. The mean and standard deviation. Like, these percentages make no sense. Unless you have a table. Actually. Oh, I'm an idiot. I am so dumb. I've worked it out. Oh, that actually is so frustrating. It's because it's between 1 and -1. Not from 0 to 1. Okay. So 16% so that's going to be this one down here. So this is female 1, who's 160.6. So it is this person here. Okay, so I was right the first time in that thinking. Because, okay, so this is female 1, because 16%'s left over here. So if 68%'s here, That means 32% is on the outside, which means that 16% is half of that. Okay, and then so the 97.5, so that is correct for this one here, because 95 plus a 2.5% for the leftover. Okay. Okay, so I need to work out what the difference between these two are. So 175 minus 160.6, I need to divide that by 3, and that's going to give me what each standard deviation is worth. 175 minus 160.6, so it's 14.4. Okay, so 14.4, so 160 plus 14.4, 160.6 plus 14.4 means that this is going to be, oh, divided by 3. Of course. So 14.4 divided by 3. Put it divided by 3. So it's 4.8. Okay, so between here and here is 4.8. So if I add 14.8 to 160.6, so 4.8, that's going to give us 165.4 as the mean. Okay, here we go. So for females, the standard deviation is equal to 4.8, and the mean is equal to 165.4. There we go, that's what I was missing. Okay, so now for males, sigma is equal to, and mu is equal to. So mu is 1.05 times that. Yep. So 1.05 times 165.4, which is 173.67. And their standard deviation is 1.1 times 4.8. So 1.1 times 4.8, which gives us 5.28. Okay, so now that we've got those two values, what that means we can do now is we can work out what this other person... So a selected male is taller than 84% of the population. So 84%, so that means he's one standard deviation above. So the male so the selected male is equal to, so it's going to be 173.67 plus 1 times 5.28, okay? Because he's one standard deviation above. Okay, 1.73 times 67 plus 1 times 5.28, which I don't really need to do that bit. So he's going to be, so 178.95. So therefore, the selected male is 178.95 centimeters tall. And with that being said, that is the end of the paper. We are going to start the advanced section. Ugh. So we get a bit longer for advanced, which is good, but it also means it's going to be a bit harder. Okay, advanced paper, here we are. So same rules as before, 10 marks I can skip if I need to, and I might actually need to skip stuff in this particular exam, because, well, at least in the next two, because they're a bit tougher. Okay, question 1. Which of the following is equivalent to sine squared 5x? So sine x plus, or sine squared x plus sod squared x is equal to 1. So sine squared, it doesn't matter what the angle is in here, 1 minus cos squared 5x. 1 minus cos squared 5x, so it's b. What is the value of x? So probability density function, so it's going to be 1 times 0.6 plus 2 times 0.3 plus 3 times 0.1. So 0.6 plus 0.6 plus 0.3. So it's going to be 1.2, so it's 1.5. Okay, cool. Which of the following represents the function, the domain of the function? So domain is things I can put into this. So for ln of x, the domain is when x is greater than 0. You cannot put 0 into a logarithm. No, you cannot. So for ln of 1 minus x is going to be when 1 minus x is greater than 0, or when minus x is greater than -1, or when x is less than 1. So it's going to be from negative infinity up to 1, not including. So D. The following, the number of downloads and so on. Oh, this is the one we had before. This is C. So that's the same as the standard one. And this is also the same as the standard question. So that one was also C. So pretty good, like when we have the double ups. All right, chocolates in a box. You have 3 peppermint. We've done this one as well. It was 15 on 28. But there's a lot of overlap. Okay, this is not an overlap. Okay, so we've got the diagram shows part of y is equal to f of x, which has a local minimum at x is equal to -2, and a local maximum at x is equal to 3, which of the following shows the correct relationship between the second derivative, 0, and the first derivative. Okay. So the second derivative at -2 is a positive. The first derivative at 3 is equal to 0. And the function value at 0 is also positive. So the function value at 0 is here. It's going... Oh no, it's negative, sorry. Negative. I was thinking of the derivative for some reason. So it's below 0. So that means that this is the smallest, followed by the first derivative, and then followed by the second derivative. So function first, it's a for that one. Okay, pretty easy, pretty straightforward. Okay, which of the following could be the equation for this graph? Okay, so it's going up to a stationary point here. We've got one value over here, which is negative. So that crosses out u and u immediately. It's weird. B and C. So now we need to look at the second intercept. Now it's a positive intercept, so it's when x is going to be positive, so it's going to be C in that case. Okay, let h of x be equal to f of g of x, where the function f of x is an odd function and the function g of x is an even function. The tangent to y is equal to h of x at k, x is equal to k, where k is greater than 0, has the equation y is equal to mx plus c. What is the equation of tangent to y at x is equal to negative k? So, even function... I always get these mixed up. So, odd function's the one that's a bit weird. So, f of x is equal to... f of negative x, and for an odd it's f of negative x is equal to negative f of x. Okay, where f of x is an odd function and g of x is an even function. So that would mean that in that particular case that could possibly be equal to that. So at x is equal to k, negative k, it's got to be the same thing, right? So if I have a function of a function, right? F of g of x, okay? Now I know the first function is odd. No, the function on the inside is even. So that means I could put f of x in or f of negative x. They give me the same thing. So these two things give me the same thing, so the same value. So So f of g of x, I need to stop doing that, is the same as f of g of negative x, okay? So those two are equivalent terms. Now f of g of negative x ooh, actually, so it's odd. So what this is saying now is this guy can be rewritten as negative f of g of negative x. I think. Which is the same as f of g of x. Okay, so all three of these things are equivalent to each other, I think is what this is saying. So the tangent to h of x at x is equal to k. So if I put k into this, I can have negative k in there. And I could also have... So I think it's just the same thing, isn't it? What's a function that's both even and odd? A parabola and a cubic. So let's try that. So I'll go at x is equal to, say, like negative 2. F of x, or g of x, is equal to x squared. F of x is equal to x cubed. Okay, we'll just do it, make it simple. So minus 2 goes in there, we get 4. And 4 goes into there, and we get whatever. Now if we put 2 in, we get 4, and we get the same thing. Okay. So it would produce the same thing as this. It has to give the same value. It has to give the same value. Because the even function is just going to transform it back into the positive value anyway. Like, it doesn't matter what you do. So if I use a negative or a positive value, it's still going to produce that positive answer. It's still going to produce the same answer as f of x. And then x cubed... Oh, hang on. So what I'm saying is this is equivalent to this, which you don't normally say. So at x is equal to k, we can substitute those values in. No, I think I'm pretty happy with A. Okay. The line y is equal to mx is a tangent of the curve y is equal to cos x at the point where x is equal to a, as shown in the diagram. Here's a, here's y is equal to mx. Which of the following statements is true? The gradient... Okay, let me decompose this a little bit better. The line y is equal to mx is a tangent to the curve y is equal to cos x at the point where x is equal to a, as shown in the diagram. 1 over a. A is just a bit before 1. Okay. So the gradient of y is equal to... So rise over run. So my rise is a, and my run is... No, sorry, my run is a, my rise is a bit below a. Or a bit below 1. Because I don't think it's meant to be quite on the line, because the tip is here. That's the height, so less than. So y... Actually, I can write it like this. Y is less than 1 over a. So it's just a little bit less than 1 over a. Which is the gradient. So m is less than 1 over a. Okay, so I'm happy with this inequality. So m is less than 1 over a. Okay. Now 1 over 2 pi. So 1 over 2 pi... 1 over 2 pi. How does that relate to this question? So 2 pi is the period. Two pi is the period. Okay, well, I can cross that one out because that inequality is not true. So how does 2 pi fit into this? 1 over 2 pi. So 2 pi is this whole thing here. 1 over 2 pi. Well, okay, well what's 2 pi equal to in cosine? What's the value at 2 pi? Jeez, I don't know. I don't know how to do this bit. So 1 over 2 pi. Well, actually, let me think of what the number would be. 1 over 2 pi. 0.15. Well, it has to be the smallest number there, doesn't it? Because if you think about it, if the smallest number is pi, whoops. If the smallest number is 1 over 2 pi, because m is less than 1 over a, and a is almost equal to 1. So a is almost equal to 1. So 1 over a... Oh, hang on. A is almost equal to 1. No, because 1 over a is bigger. Yes, that's right. So m is less than 1 over a. Okay, so that's that bit there. And then, so 1 over 2 pi... Like, because it's not much smaller, and then 1 over 2 pi must be the biggest. Okay, so I'm thinking B. B is my final answer. Let's move on. Okay. Same number, 69. Student number, 420. Let's keep going. Okay, solve the equation. We did this one before. So the trick was to make everything over 2. So you get 2x over 2 plus x minus 1 over 2, because it's already over 2, is equal to 18 over 2. Cancel, cancel, cancel. You get 2x plus x minus 1 is equal to 18. So we get 3x minus 1 is equal to 18. 3x is equal to 19, and then x is equal to 19 on 3. Now I'm not going to check it this time because we did that in the last one and that was the same solution we got. The exact same problem here as well. Okay, I remember from then, that was 8. Can't remember what the other value was, and I'm not going to cheat and go back. We're actually going to work it out. So find the length of xy. Well, we have to do it anyway. Correct the two places. So adjacent, so it's cos. So cos 30 equals xy on 16. So xy is equal to 16 cos 30 degrees. So xy is equal to... Okay, and this is where we get our trusty calculator out. 16 cos 30 degrees, and we get 13.86. Hence find the area of the shaded region. So area total equals area, go area semi, so draw that little thing, it looks too much there, it's semi, minus area of the triangle. So it's a half times pi times the radius, which was 16, so squared, 8 squared, diameter was 16, minus the triangle, which was a half times the breadth, or base times the height, 13.86. Okay, throw that into a calculator, and we're going to get 45.09, and that's centimeters squared, I think. Yes, cool, done. Okay, find the exact gradient of the tangent of the curve y is equal to x tan x at the point where x is equal to pi on 3. Find the exact gradient of the tangent. Okay, so we're just looking for the gradient, so if y is equal to x tan x, then dy dx is equal to, it's a product rule, so it's uv dash plus vu dash uv. So u is equal to x. Oh, we'll go like this. U dash is equal to 1. V is equal to 10x. And, oops, v dash is equal to 10x. Now, the derivative of 10x, I can't remember. Hoping it's on the formula sheet, something that we have been given. That's what I'm typing in, just the formula sheet. 10x, I can't remember. It's not cot. Something weird, like sec or cosec or something. Yes, it is. It's sec squared x. That's right. Okay, sec squared x. So u times v dash. So x times sec squared x, or sec x squared, plus v u dash. So 10x times 1. So it's just that. Now at x is equal to pi on 3, we get our gradient being equal to pi on 3 times sec squared pi on 3 plus tan of pi on 3. Now I can't remember what these values are. Sec is 1 over cos. So if I change my thing to radians, we get, so 1, oh, well, what's cos of pi on 3? Pi on 3 is 60 degrees. So it's 1 over cos squared pi on 3 plus tan of pi on 3. Now tan of pi on 3, so 60 degrees is root 3. Tan of pi on 3 is just root 3. Continue it over here. Okay, so cos of pi on 3, cos squared of pi on 3. So cos of pi on 3 is root 3 on 2. So it's 1 over 3 on 4. So it's 4 on 3 plus root 3. So pi on 3, 4 over 3 plus root 3. I hope that's right. Root 3 on 2, yeah, it should be. So 4 pi on 9 plus root 3. Or 4 pi plus 9 root 3 on 3, like that, if we really wanted to. Oh, on 9, sorry. If you really wanted to put it together like that. Which is not really necessary. But anyway, that's the gradient of the tangent at that point. So the first term of an arithmetic sequence is 5. The sum of the first 43 terms is 2021. What is the common difference of this sequence? The common term is the sum of the first 43 terms. So sum formula, sum of a arithmetic is equal to n on 2 2a plus n minus 1 times the difference. We know that the sum is equal to 2021. We're looking for the 43rd term, so n is equal to 43. So it means the sum of the 43 term is that. The first term is our a term, is 5. And we're trying to find the difference, so d. Cool. So 2021 is equal to 43 on 2, lots of 10 plus 42d. Okay, so we're going to get 4042 on 43 is equal to 10 plus 42d. 4042 over 43 minus 10 is equal to 42d. And so then d is going to be equal to, it's going to be all of this, I hope. And let's get an answer. Let's go HSC Speedrun. It says Lane. Actually, I've got a little bone to pick with you, Lane. I haven't seen you on my gaming stream in quite some time. What's going on there, matey? Minus 10 over 42 equals 2. Well, there you go. Difference is 2. Just to get an answer of 2. You could have probably guessed that in the HSC, to be honest. Like, I wouldn't, but you probably could. I actually thought that might have been the case, so I'm really glad that that's worked out. Okay, so I'm going to rewrite this as 2x plus 4 to the power of a half dx. Now, when you differentiate this, you would bring the half down the front and then the derivative inside the outside. So it's going to be derivative comes out the front. So derivative comes out the front. So it's going to be 3 on 2, isn't it? So 2 on 3 times. Now, normally the derivative comes out. So fraction comes down and then you subtract 1. But we need to add 1 and then divide through. Yep. So derivative comes down, you multiply by that. Yep. So 2 over 3 times a half. 2x plus 4, and then you add 1 to the power, so 3 on 2. And that's from negative 2 to 0. So you got a third of 2x plus 4, 3 on 2, and that's from negative 2 to 0. Okay, put that in, we get a third. Lots of 0 plus 4. Power 3 on 2 minus, so that's the first bit, and the second bit is a third, and it's going to be 0, lots of 3 on 2. So that bit cancels out. That's good, that's good, that's good, we like that. Okay, so this last bit, so 4 to the power of 3 on 2. Because the square root of 4 is 2, and then 2 cubed is 8. And you can do that either or, so you can go the other way around as well. So 8 to the power of 3 is, what, 64? Something gross, I think. Let me just do it. 4 to the power of 3 on 2. 8, cool. Yep, happy days. Alright, next question. What is the value? For what values of x is that increasing? So increasing means dy dx is greater than 0. So if f of x is equal to this, x, wow, minus 2. I need to stop doing that, I think. Stop being lame. Thank you. Alright, so 2x cubed, then the derivative is equal to 2x minus 8x squared, okay? And now we're looking for when f dash of x is greater than 0. So in other words, when 2x minus 8x squared is greater than 0, so we're going to factorize this. We're going to get 2x lots of 1 minus 4x is greater than 0. Okay. So solutions to this would be when x is equal to 0, and 1 minus 4x is equal to 0. So minus 4x is equal to minus 1, so x is equal to a quarter. So now I need to test whether it's on the inside or the outside it's greater than 0. So test x is equal to, let's try 1, that's an easy one. F dash of 1 is equal to 2 lots of 1 minus 8 lots of 1 squared equals 2 minus 8, which equals negative 6. So that's not what we want, so therefore f of x is increasing, I think it was. Yep, f of x is increasing when it's between those two values. So it's not when it's equal to those two values, because that's when it's equal to 0. So yeah, it has to be like in between or outside of it. Can't be equal to it. We've done this already. Okay, so this first one we had to okay. So 29.2 minus 0.011 times 540 equals 23.26 degrees Celsius. Whichever value is a gradient in a given context. So the given context is, what did we say? We said it was when temp, no, not temp, when, oh, the higher the sea level, or the higher the town is above sea level, the temperature drops. By negative 0.011 degrees Celsius. Something like that. Graphical below is the equation, blah, 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 blah. This is the one where we just have to say that we should use latitude as the Pearson's correlation coefficient is stronger, although negative. Doesn't really matter if it's negative or positive, we want a stronger one. Okay, this is like another question that we've already done too. This is actually ridiculous. Find the size of the obtuse angle ABC correct to the nearest degree. Okay, so again it's the sine rule. So sine A on A equals sine B on B. So we don't know what capital A is. Oh, well, we know it's ABC. I think that's what we're trying to find. Yep. So ABC, so this angle in here, over 25 is equal to sine B, which is our 28 degrees, so sine 28 degrees over our B value, which is 16. So therefore we're going to have sine ABC is equal to 25 sine 28 degrees over 16, so sine ABC is equal to is equal to oh well, not sine ABC, we want just ABC, so angle ABC is equal to sine -1 of 25 sine 28 degrees over 16. So ABC is equal to, okay, so go sine -1, 25 sine 28 degrees, and we're still in radians. Dear. Over 16, that's right, because I did 4 last time for some silly reason. And we get about 47 degrees. Continuous degree, yeah, 47 degrees. Cool. Without using calculus, sketch the graph of that showing the asymptotes and the x and y intercepts. Is that a way to do that? Oh no, and then it's the, okay, so then A, B, C. Cute. Choose equals 180 minus 47 degrees, which is equal to 133 degrees. Yep. Okay, without using calculus, sketch the graph of y is equal to 2 plus 1 on x plus 4, showing the asymptotes and the x and y intercepts. So they don't give you a box to graph it in, but that's okay. Alright, so So 1 over x looks like this. It's like this. Okay. Oops. I just want a bit more space for this one, I think. Okay, so 1 over x looks like this. Now the x plus 4. So when you're adding 4 to the x, it's the same as x minus k, so it's -4, so it's pushing it back -4 spots. So at the 1, 1s. So where it's 1, 1, it's going to be pushing back 0, 1, 2, 3. Here. And the 2 on the front is going to push it up 2 spots. So it's going to hit there. 1. So it's going to go like that. Okay. So, actually drawing this properly, I want it more in sort of, I want more of this side. Like that. So 1, 2, 3, 4, 5, 1, 2, 3, 1, 3. So it's going to look something like 1, 2, 3, 1, 2. So something like this. And it's going to be at 2. So something like this. So that's going to be at 2 there. -1, 1, 3, -2, -3, 1, 2, 3, 4, 5. And so it's essentially gone back 4 spots. So if it was here, it's going to be 1, 2, 3, 4. So here it's going to be pushed up to 1, 2. So this is the other spot there. And so this has got to go through like that. Yeah. Because it doesn't want to touch the 4. It wants to get close to 4, but it doesn't want to touch the 4. So like that. And we can get rid of all this rubbish over here. Don't need. Okay, and what's the information we need to add on? We need to showing the asymptote, plural. So there's one going like this. So that's asymptote number 1, and asymptote number 2 is going through 2. So those are the asymptotes, which means that this guy's going to come closer like that, because he's not actually going to touch like that. Something like that. Okay, and we also need the x and y intercepts. So the x and y intercepts I think we can just work out by calculating them into the equation. So when is y equal to 0, when is x equal to 0? So when x is equal to 0, so when x is equal to 0, so x is equal to 0, we get y is equal to 2 plus 1 over 4. So y is equal to 2 1/4. X int at, well, that's the y int, isn't it? Y int. Y int at y is equal to 2.25. And the x is when at y is equal to 0. So 0 is equal to 2 plus 1 on x plus 4. So negative 2 is equal to 1 on x plus 4. Flip them around, we get 1, negative 1 on 2 is equal to x plus 4. So we get x is equal to negative 4 minus a half. So x is equal to negative 4.5. So x int at x is equal to negative 4.5. Cool. And there we go. So that's all we need for that one. Okay, for what values of x in interval list does the line y equal to 1 intersect with the graph of y is equal to 2 sine x for x? So we're solving these simultaneously, I guess. So that's my two equations put into one. Oh. So one is equal, so we get a half is equal to sine of 4x. Like this. Okay, so when is sine of x normally equal to? So sine of theta is equal to a half when theta is equal to pi on 6. Pi on 6 5 pi on 6, 13 pi on 6, and 17 pi on 6, etc. So 4x is going to be equal to this. So remember, we're letting theta be equal to 4x, so x is when it's equal to pi on 6, 12, 18, 24, 5 pi on 24, 13 pi on 24, and 17 pi on 24. So those are the values. For what values of x in the interval that does the line y equal 1 intersect the graph? So intersects at x is equal to pi on 24, 5 pi on 24, 13 pi, I don't know why I'm writing this all again, 17 pi on 24. But it's between pi, oh, okay, so it's between pi, that and pi on 4. So it intersects at those 2 points on the interval. Like that. So those are the only two values, because I think 6 pi on 4 would be the absolute limit for that one. So it's a quarter of what we normally would ask you. So that's pretty cool. Okay, so consider the graph as shown. Sketch the graph of y is equal to 4y. 4 function 2 of x. 4 lots of the function which is 2 of x. Showing the x-intercepts and the coordinates of the turning points. Okay. So if I have 2x on the inside, that is a transformation of a dilation of 2. So it's effectively stretching the whole thing by 2. So it's like dragging it out. It's pulling it out. Okay, because if I normally would have put 1 in, and it gives me a position of 3, if I put 1 in now, it's producing what 2 would normally produce. So it's essentially it's like doubling the values across. So, and then the 4 at the front, the 4 is just stretching it by 4? Yes. No, it's compressing it by 4. Ooh, I need to think. So 2x, so we put 1 in normally, and it would produce the result of 2. So if I had, like, say, y is equal to x squared, just as a little... So 1... No. Okay, so the inside's compressing it by 2. So it's halving all the x values, and then it's stretching all the y values by 4. So halving all the x, stretching all of the... Okay, so 3. This is going to come across to 2, but it's going to come down to negative... Oh, it's going to come well down. It's going to come down to... negative 32. So essentially what we're going to end up with is something like this. Yeah, so this is going to be 3, 0. This turning point is going to be to negative 32. Okay, because this value halves everything, whereas this value multiplies. So, sorry, let me rephrase that. This value divides everything by 2. This value multiplies everything by 4. Yeah, cool. And this, so this is not touched. And that's pretty much it, yeah. Okay, I'm happy with that. Above on graph. So the HSC markers know where I've drawn it. Okay. Oh, this is a stupid question, isn't it? Oh no, this one's a different one. Using the table, find a probability of a value from a random variable that is normally distributed between 0 and 1 lies between 0.1 and 0.5. Wow, that's so much easier. What the hell? Between 0.1 and 0.5. So it's just this and this. Yeah, okay. So 0.5 equates to 0.1915. 0.1 equates to 0.0398. So the probability that's between 0.1 and 0.5 inclusive is just going to be 0.1915 minus 0.0398. See, that's what it should have been. Like, that's so much easier. Like, come on. Alright. Calculator time. So the answer is 0.1517. Cool. So birth weights, blah, 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 blah. Okay, so first finding is Z score. And standard deviation of 570. But first calculating a Z score. Find how many babies out of 1,000 are expected to be birth weight greater than this. So 5280. Now, so before, I worked out what the proportion was, didn't I? So it was like 3870 minus 3528. So 342. Okay, and then it was the proportion of that to 570. So 342 over 570. That gives you 0.6. Okay. And so we do 1,000 times, and then so the value for 0.6, 0.2257, or hang on. How many values are expected to have a birth weight greater than that? So up to that point, so this is, so we need to add 0.5 to that. So before we do this, it's going to be 0.5 plus 0.2257. And we're going to take this and we multiply it by 1,000. Actually, we could do it the other way. 1 minus that. Yeah, we'll do it this way. 0.2257. Okay. So that's 1 minus the answer. So this way actually, so that is equal to 0.7257. And then, so 1 minus 0.7257. So this is for the baby's grader, which is equal to 0.2743. Then we do 1,000 times 0.2743, and we get, therefore, 274 babies should be greater than 3,528 grams. Oh, okay. Okay, so B is a positive constant, so we need to find what that constant value is to begin with. Okay, so at t equals 20, we've got a population of 1250. So substitute that into this equation, we get 1250 is equal to 5,000 b negative 20 on 10, so just a negative 2. Okay, so 1250 on 5,000 equals b to the negative 2. Which is the same as that. Which is the same as that. Which is the same as that. So my b value in this case is 2. Oh, that's very conveniently done. Find the value of t corrected one decimal place for which the instantaneous rate decrease. Okay, so we know what the equation is now. So the equation is p is equal to 5,000 times 2 to the negative t on 10. So find the value of t correct to one decimal place for which the instantaneous rate of decrease is 3,000 people. Okay, so dp dt, so derivative comes out the front, so negative 1/10 times 5,000 times 2 to the negative t on 10, because it's exponential, doesn't change. So we get negative 500 times 2 to the negative t on 10. And we're looking for when the rate of decrease is 30 people per year. So looking for when dp dt is equal to negative 30, because it's decreasing, it's going down. So let's substitute what we know. We know this. We're trying to find that. So negative 30 on negative 500 equals 2 to the negative t on 10. Okay. So to remove the logarithm, well, to get this out of the top, I'm going to take a log of both sides, a log of base 2. Go 3 on 50. Simplify it down. It's equal to log 2 of 2. That. Okay, so knowing our log laws, we can rewrite this as negative t on 10 times it by 10 and put a negative out the front. And do a change of base really quickly. So minus 10 times, let's say log of, we'll just do ln. And t is equal to whatever that is. So let's work it out. So it's minus 10 times ln of 3 on 50. So change of base in this case being our log base e. ln of 2. We get t is equal to about 40.5889, blah, 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 blah. And so the initial question itself, find the value of t correct to one decimal place for which the instantaneous rate is that. So therefore instantaneous rate is decreasing at 30 people per year. When t, I want to say, when t is equal to 40.9. There we go. Okay, we're about halfway. Cool, cool, cool. The curve y is equal to 3 over x minus 1 increases the line y is equal to 3 on 2x at point 2, 3. The region bounded by the curve y is equal to 3 of x minus 1, and the line y is... Okay, so it's basically all this. Find the exact value of the shaded area. Okay. So half of this is actually quite easy. Half of this is just a triangle, so it's not an issue, with 2, 3. So that's my 2 value there. So basically, so from 0 So from 0 to 4 of whatever my function is, so f of x dx can be made up of 0 to 2 of the triangle plus 2 to 4, and the function is 3. Okay, gross. I'm going to rewrite it like this, because it's much easier to deal with. Okay, so it's a half times the base times the height. We'll just put it in. So half times 2 times 3 plus, okay, now this bit here, a little bit harder. Okay, so derivative of the inside is 1, so 1 divided by 1, and then we're going to, we're going to do something gross, aren't we? It's a logarithm. Okay, so the log in this case, I'm actually going to go back and rewrite you as you were, because it's a log. Now, the reason why I knew this was a log is if I had it in that other form, you would subtract 1 from the power, which would give you a 0. Or sorry, add 1 to the power, which would give you 0, which is what we don't want. So this guy here can actually be rewritten as 2, 4, 3 times 1 over x minus 1. And now because the derivative of the top is just... Sorry, the function on top is the derivative of the bottom. We've got our nice logarithm. Okay. So it's going to be 3 ln of x minus 1 from 2 to 4. 4 to 2, whichever way you're going to say that. 4 minus 1 plus... Find the exact region. No, minus even. Actually, I could have brought that out, couldn't I? Let's do a little bit of manipulation. So equals 3 plus 3 lots of ln of 3 minus ln of 1. Okay, well log of 1 is just 0. Any log of 1, so it's going to be 3 plus 3 log of 3. Okay, and there we go. And then if you want to make it even simpler, something like that. But that's just not necessary. Whatever. Something like that. Oh, we did this one already. Okay, so it was the 8th year and then the interest rate, wasn't it? So I think it was U. So what is it? $1,000. So first 8. It's 8.2132. $8213.2 plus 2 years, which is equal to 8213, 1 plus, and the rate was 0.0125 to the power of 2. Power of 2 for 2 years, we get 8419.81. Yep, that's it. So you don't actually need that much working out to do that one. So total in account after 10 years is 8419.81. Okay, a particle is shot vertically upwards from a point 100 meters Above ground level, the position of the particle y meters above the ground after t seconds is given by this. Find the maximum height above the ground level reached by particle. Okay, so we can just do a minimum turning point, or maximum turning point in this case. So max height is when dy dx is equal to, or dy dt in this case is equal to 0. So dy dt is equal to 0. So if y is equal to negative 5t squared plus 70t plus 100, then dy dt is going to be equal to negative 10t plus 70. Okay, so when is this equal to 0? So 0 is equal to minus 10t plus 70. So minus 70 is equal to minus 10t, so t is equal to 7. So find the maximum height above ground. Okay, so sub into yt, we get y of 7 minus 5 lots of 7 squared plus 70 lots of 7 plus 100, because this is going to give us our height, which is equal to minus 5 lots of 7 squared plus 70 lots of 7 plus 100 equals 345. So 345 meters, so max height equals 345, and I think it's meters. Yep. Okay, find the velocity of the particle in meters per second immediately before it hits the ground, leaving your answer in the form A. So immediately before hitting the ground, let's just say when it's hitting the ground, so like the value when it's at that specific bang point. So we're looking for the x-intercept. So x-int. Start off with this, so we've got our equation. So we're looking for this minus 5t squared plus 70t plus 100, yep, plus 100. Okay, let's take a factor of negative 5 out, so that gives us t squared minus 14 t minus 20. So 0 is equal to, so factorizing this, we get, so two numbers that multiply to negative 20 and add to negative 14. Add to negative 14, so what, 7 and 2? Well, they're both going to have to be, one's going to have to be negative, one's going to be positive. I'll just double check that. Yeah, that's fine. Okay, let's do the factors of 20. 120. It's negative 20, negative 2. 10, negative 4, 5, negative 5, 4, negative 2. Oops, negative 10, 2. Negative 20 and 1. So which ones of those gives me 14? Add to 14. None. Can never be easy numbers, can it? Okay, another approach. Let's just quadratic equation this sucker. Okay, so t is equal to negative b, so 14 plus or minus the square root of b squared minus 4 times a times c all over 2. So 14 plus, let's start with the plus. So 14 plus the square root of 14 squared minus 4 times 1 times negative 20 on 2 gives me 7 plus root 69. Yep. Okay, some beautiful numbers to work with. So we know what the two intercepts are now. So what we're looking for now is when, so now for the velocity at t is equal to 7 plus root 69. So dp dt again, so that's, or dy dt I should say, minus, so dy dt minus 10t plus 70, like that. Cool. So at t is equal to 7 plus root 69, we get minus 10 lots of 7 plus root 69 plus 70, which is equal to minus 70 minus 70 plus 70 minus 10 root 69. So dy dt is equal to minus 10 root 69. Oh, it actually worked out a lot nicer than I was thinking. Good. And that's all I need. Yeah, so therefore, velocity just before hitting ground is minus 10 root 69 meters per second. Cool. Alright, Kenzo is a solar powered phone charger. P is modeled by the function that. Sketch the graph. Oh, I hate these. Okay. It's got a nicer line than that, I think. Okay, so typically the inside's going to be cancelled out because the pi on 12. Sorry, the radians are going to be cancelled out because of that on the inside. The 400 sign just means it's going to be stretched by 400. So instead of being 1 and negative 1, it's going to be 400 and negative 400. Okay, so typically we would have, so something like pi on 2, pi, 3 pi on 2, and 2 pi as our t values. So if I was to substitute these values in, So let's just say we start with pi. So we get pi squared on 12. That's so stupid. See, 12 on pi would make much more sense in this case. But pi on 12? Okay, well let me think. How would that be stretching it? So the t is changing to pi on 12. So it's a stretch or a dilation along this way. So it's a dilation along this way. So are we stretching it out or are we compressing it in? That's the question. So pi on 12, so it's t over x, so it's x over k is the dilation, so it gets stretched out. So in this case our k is equal to 12 on pi. So all the values for our x are being it's gonna look like that. And all our values for k, so all our t values are going to be changing by a factor of 12 on pi. So I need to multiply. Let me think. Okay, so if I'm changing x squared to x on 2 squared, so x squared is changing squared. What happens to the function? So if 1 goes in, I'd get a half instead. So it's compressing, so it's dividing by that k value. Okay, so it's dividing by 12 on pi. So pi on 2 is being divided by 12 on pi, which is what I just worked out, isn't it? Pushing in by that factor. Hang on, let me think. So if I had like this, I started with 1, 1, and 2, 4. Okay, so I put 1 in, I get half. I put 2 in, I get 1. Put 2 in, I get 1. So I'm dividing these values by this value. I am dividing. Okay. Okay. So if I have pi on 2, and I divide that by 12 on pi, yeah, it's going to give me this stupid... Okay. Oh, I hate these stupid graph questions. Dividing it by pi on 12. Or 12 on pi. Pi on 12 will make it so much easier. I think. Although, no, it doesn't make it... No, it would. I think it actually would make it easier. If I had pi on 12. But it just doesn't make sense logically when I think about it. by the number on the bottom. I'm dividing by 12 on the bottom. Dividing by 12 is the same as t over. It just makes so much more sense if it's the other way around. It's 12 on pi. Whatever. I'm going to pretend. I'm going to pretend it's the other way around. Because I can't see how it works when it's 12 on pi. Or pi on 12, I should say. I'm multiplying it by a half in that case, aren't I? So if I put 1, if I put like 6 into that. 1. The transformation plus 3. Oh, I'm just going to quickly cheat with something. No, because the values you're putting in are... Okay, I've got it the wrong way around. Yes, I'm right. I'm right. Okay. Jeez. Okay, so these numbers get swapped around. So you're timesing by the number on the bottom, so 12 on pi. So it's going to be pi on 2 times 12 on pi, which is going to be 6. So that's my 6, that's my 12, that's my 18, and that's my 24. And so that's my cutoff there. Okay. That was so much more painful than what it really should have been. Okay, and I'm going to cut that off there like that. Okay. Power is the rate of change of energy. Power is the rate of change of energy. So energy is the integral. Yep. Hence the amount of energy, E units, generated by the solar powered phone from t is equal to A to t is equal to B, where 0, A, B, 12 is given by this. Yeah, that makes sense. Show that E is equal to this. Okay, that's pretty easy. It's just the generalized form of it. Okay. So if E is equal to, from A to B, of PT dt, and P of T is equal to 400 sine of 12 on pi, no, pi on 12, t. Yep. Okay. So this is going to be from A to B of 400 sine pi on 12t dt, which is the same as 400 of A to B of sine of pi on 12 t dt. Cool. Okay, now, so sine, okay, so derivative of sine, so integral of sine is negative cos. So it's going to be negative, and then the derivative of the inside is just pi on 12, so pi on 12 cos of pi on 12, and it's my b value, minus negative, so it's going to be kind of plus, pi on 12 cos pi on 12 a. That. So I can pull these guys out and get, because I think it has the negative, yeah, okay. So I get, wait. Oh no, because I'm going to divide by the inside. I'm going to divide by the inside, not times, divide. So it's going to, these two guys are going to be flipped. So it's going to be 12 on pi and 12 on pi, yeah. Because you divide by the derivative inside when you're integrating, you multiply by the derivative inside when you 400, so 400 times 12 on pi, so we're saying on pi, so 400 times 12 should be 4800, cool. And we're going to get, so cos of pi a on 12 minus cos of pi b on 12. There we go, so that's the generalized form, cool. So make a phone call, the battery needs at least 300 units of energy. Kenzo woke up 3 hours after sunrise and found the phone battery had no units of energy. Immediately began to use his solar powered charger to charge his phone battery. Okay, so starting at 3 hours. So at 3, so we're starting here. To make a phone call, the battery power needs at least 300 units of energy. So we're talking about the integral. So it's going to be from 300 to from 3 to unknown. So it's going to be from 3 to unknown of p of t dt. So substituting it into this formula here, we get 4,800, and we need it to be equal to 300. So we need E to be equal to 300. We don't know what B is. B is our unknown. A is 3 hours after he wakes up, so after sunrise. Yep. So that's that, and then we just solve it. Okay, cool. So the formula is going to be 300, so we don't actually need that bit. 300 is equal to 4,800 on pi. Okay, A, B. So cos of 3 pi on 12, which is just pi on 4. Minus cos of 3x on, pi x on 12. Okay, that's maybe the hardest bit to work out that bit. Most space they give me, not much. Okay, let's just make a bit more space. So we'll get rid of this. Okay, lasso. This guy, and take this guy. Okay, and maybe this one up. Okay, so 300 divided by that stuff. So 300 divided by 4,800 on pi. So it's 1/16 pi, so pi on 16 minus, and I'm going to take this guy over, so minus cos of pi on 4 is equal to negative cos of pi x on 12. Okay, so pi on 16 minus cos pi on 4. Cos pi on 4 is, what's that equal to? It's going to be equal to, I think it's root 2 on 2. So pi on 4 is 45 degrees. Pi on 3, pi on 6, pi on 4, yep. So cos of that is 1 on root 2. So we've got pi on 16 minus 1 on root 2 equals negative cos of pi x on 12. Remember that's on the inside. Bring it out over here and continue it here. So cos of x, or pi x on 12 It's going to be equal to 1 on root 2 minus pi on 16. Okay, and then we're going to do some inverse cos. Pi x on 12 is equal to cos inverse of 1 on root 2 minus pi on 16. And then multiply by 12, divide by that. So x is equal to 12 on pi. Cool. And so this should give me my x value. That would work. So 12 on pi, on pi times the inverse cosine of 1 on the square root of 2 minus pi on 16. Okay, and we want it in minutes. Well, this says 266 hours, which I don't think is correct. 226 hours. Okay, let me think for a sec. So this is formula. A was 3, B we didn't know. This is positive, I guess. So pi on 16 minus, because that came over, so minus cos on that is equal to minus this. So we flip these two guys around to get the negative. I don't see what's wrong with that, to be honest. Let me get rid of this stuff. It's really big number. And I've multiplied by 12 and divided by pi. Let's see, is the number. Hey Lantern, how you going? How you doing, my friend? I'm trying to work out this stupid problem here. I just can't seem to get a number that works. Alright, I think this might be the question I'm going to skip. Because I just can't seem... So I've attempted this one, and I'm going to skip D. Because I just can't seem to get an answer out. I don't know what's going on. I feel like I've done that right, but I'm going to have to check some answers. Okay. So I have officially skipped 1 mark worth of question. I've seriously attempted this one. And I've skipped 1 mark worth of question. I'm going to move down. The region bounded by the graphical function f of x is equal to 8 minus 2x to the power of x, and the coordinate axis as shown. Show that the area of the shaded region is given by this. Okay. F of x is equal to 8 minus 2 to the power of x. Okay, we'll just integrate it then, I guess. Because it's not a... no. So from... oh, we don't know where it's from though. Okay, we have to find the x-intercept first. So if we find the x-intercept first, so find this x-int, we should be able to do it from here, okay? So, here's my function up here. So my x-intercept is when y is equal to 0. So it's going to be 0 is equal to 8 minus 2 to the power of x. So negative 8 is equal to negative 2 to the power of x. Okay, let's apply some log laws. We'll do base 2. So log 2 of negative 8 is equal to log 2 of negative 2 to the x. So we get log 2 of negative 8 is equal to x log, well that should be on the inside with that, but that's alright. Log 2 of negative 2. Oh no, it can't be negative, can it? Two to the power of what is equal to negative 2? No, you can't have negative logs, can you? So that's all wrong. Oh, you can just literally remove the negative from both sides, duh. Oh, that's so dumb. Okay, so log 2 of 8 is equal to log 2 of 2 to the power of x. Okay, let me do it this way, yep. Okay, so we get, so 2 to the power of what is equal to 8, that's 3. This is the same as x log 2 of 2 So that 3 is equal to x times 1, so x is equal to 3. Okay, so this x-intercept here is 3. So now what we can do is we can integrate from 0 to 3 of this function 8 minus to the power of x dx. Now I'm hoping that on our formula sheet we do have an integral that works for us in this particular case. So we're looking for a to the f of x, so this guy here. Okay. So that works for us. So it's going to give us 8x minus. Now the integral of negative 2 to the power of x, so we need the derivative on the outside. So the derivative is just 1 in this case, so that's fine. So a to the f of x, so minus 2 to the x over log of 2, like this. And that's from 0 to 3. Okay, and that's just on the formula sheet. So 8 times 3 minus 2 to the power of 3 log 2 minus 8 times 0 minus 0 cubed on. That doesn't just work out in general, so that's nothing. So 8, 16, 24 minus 8 on log 2, which I think is not what we wanted. Minus 7 log 2, what? Can't be right. What the hell? The whole right side cancels out. Oh, because it's 2 to the power of 0. You absolute donkey. You absolute actual donkey. So it's 2 to the power of 0 over log of, and it's log of 2 because that doesn't change. Right. Okay, that makes more sense. 24 minus 8 on log 2 minus 0 plus 1 on log 2, which is 24 minus 7 log 2. Okay, there we go. A new function g of x is found by taking the graph of y is equal to negative f of negative x and translating it 5 units to the right. What the hell does this have to do with part A? Oh, for this. So negative x of negative f of negative x. So all of the x values become negative x values and all the negative x values become x values. And it flips, so it's a rotation, essentially. Flip down. So it's going to look like this, essentially. Which is just a rotation, yeah, cool. Okay. And move to 5 units to the right. Okay, so we've got this thing here. It's going to be rotated around like that, and it's going to be pushed 5 to the right. 5 units to the right. So that would be negative 3. So it'd become 2. Okay. So what it would look like is it would look like because the other things haven't changed. So the asymptote that was at 8, the asymptote that was at 8 is going to be the asymptote that was at 8 is going to go down to negative 8. That's horrible. Okay. So 1, 2, 3, 4. No, this will do. So 8, negative 8. So we've got the asymptote coming across like this. And you've got like that. Something like that. Right? Except not drawn as poorly. So it started at negative 3, it goes to 2, it's down here. Happy days. Got the x-intercept, got the asymptote, cool. Hence find the value of that. Well, it's just going to be, so from 2 to 5, so 0 to 3. Oh, okay, right. I need to actually draw it so it stops 2. Okay, so that's the function there. It's not meant to be a triangle, it's meant to be a curve, but whatever. Okay, so 2 to 5, so it's just a negative version of this, isn't it? So it's equal to negative this, so it's going to be 7 log 2 over minus 24. So what? 2, 5, g of x dx is equal to 7 log 2 minus, because it's the opposite, minus 24. So all positives become negative, all negatives become positive. Yeah, cool. Alright, section 1 is done. Cool. Gotta do for the memes. Alright. Oh, money. I hate money. Like, I love having money, but I hate answering questions about money. Okay, we've got an hour of 50. Should be right. Okay, on the day that Megan was born, her grandfather deposited 5k into an account, earning 3% per annum, compounded annually on each birthday after this. Her grandfather deposited $1,000 in the same account, making the final deposit of Megan's 70th birthday. There's a total of 18 deposits were made. Let AN be the amount in the account. The amount in the account. Amount in the account. On Megan's nth birthday after the deposit is made. Show that A3 is equal to that. That's what it is on. Okay, so it's a pattern type thing. So A1 is equal to A0 times so A1 equals whatever that is. $5,000 times 0.03 equals 150, so it's going to be 150. Let's do 1.03. So then A2 is going to be A1 times 1.03 plus. So essentially, for this problem, the sequence will start here. This is what I'm getting. Because the amount that's going in is changing after this particular date. So you're adding 1,000 after this. So 150 times 1.03 plus 1,000. Because he puts 1,000 in? Yeah. So A2 is equal to 6304. 0.5. This is going to look embarrassing if I don't get this last bit. So then A3 is A2 plus 1.03, oh sorry, times 1.03 plus 1000. This would be 6304.50. That's money. Times 1.03 plus 1000. Okay, so do the same calculation. And we get, unless this is 0. No, that doesn't make sense though. Oh dear. 7493.63. Or 64. And if we chuck that in again, then we get something bigger. What the hell is going on there? Yeah. Okay. Oh no, I've worked out. So A1, okay, so A0, yeah. A0 is equal to 5k, okay? And then you start at A1 by adding 1000 in. So that one's going to be 6150. Hang on. Yeah, no, because the money won't be calculated till after the fact. Yeah, okay, that makes sense. Okay, so 6150. So let me delete some numbers. And fill them in with the numbers I need. Okay, so 6150. This is looking a bit more promising. Yeah, cool. Cool. Okay, that works. Alright, so we've got this bit. So A0 is equal to A1 is equal to, okay, so the sequence does not start there. Like I so stupidly thought. Okay. On a 7th birthday, after the final deposits made, Megan has 30k in her account. You're not required to show this. Megan has decided to leave the money in the same account, continuing to earn interest at 3% per annum compounded annually on her 18th birthday. Each birthday month, Megan withdraws 2k from the account. How many withdrawals of $20,000 will Megan be able to make? Okay, so she has 30k. So we need to work out what the sequence is going to be. And we're looking for when n is equal to 0, essentially, I think, for this one. So maybe you can get my sequences stuff up. Okay, so this would be, okay, so this is a new sequence. So A0 is equal to 30,025.83. So A1 would be equal to A0 times 1.03 minus 2,000. Okay, then A2, and I'm going to leave this in general form this time, I think. It's just going to be more useful. So A1 times 1.03 minus 2000, which is equal to 30025.83. So 1.03 minus 2000 times 1.03 minus 2000. So this is equal to 30025.83 times 1.03 squared minus 2000. It's 2000, okay? I'm going to do one more just to see the pattern. So it's going to be A2 times 1.03 minus 2000, so which is equal to 30025.83 times 1.03 squared minus 2000 times 1.03 minus 2000 times 1.03 minus 2000. So this is going to be equal to 30025.83 times, and it's going to be this bit because this is just one term, so 1.03 cubed minus 2000 times 1.03 squared minus 2000 times 1.03 minus 2000. Okay, so I've seen a problem like this before. So you've got in one part a sequence that's increasing, and you're also taking away a sequence that's going down. Okay, so you've got this sequence here that's continuously increasing by a factor of 1.03, and over on this side you've got a sequence that is going down by a factor of, well, now let me think about this. (2000 times 1.03). No. Oh, I can't quite remember. Anyway. So we're essentially looking for when this is equal to 0. So when n is equal to 0. So let's rewrite this in a formula for n. So an is equal to 30025.83 times 03 to the power of n minus 03 to the power of n minus 1 minus 2000 times 1.03 to the n minus 2, 2000 times 1.03 to the 1 minus 2000. Okay, so that's the generalized form. So whatever an is, actually, it doesn't change. It's just this bit in the end that's changing. So we need to work out the sum of this sequence here. So I can rewrite this as etc. down to the last bit. Because we're going to be taking off the sum of that anyway. Okay, so what we need to do is we need to add up the sum of this, which is n minus 1 less than what it is. So now this bit here is going to be the sum of a geometric series because it's going up by 1.03 each time. So you're multiplying each term by 1.03 to get to the next one. So my R is 1.03. My N value, we don't know. My A value, my starting value was 2000. Okay, so if I flipped it around, and my, is that all I need? Yep. So it's going to be a to the Rn minus 1 over R minus 1 minus, okay, so substituting these values in, 2000, 1.03 to the power of n, minus 1, over 0.03. Okay, so now that I've got this part, n minus 1, isn't it? It's not n, because n, my n value is n minus 1. Because it's 1 less than the term we're on. But we also include 0 too. Yeah, so it is just n actually. Okay. Now we're looking for when this abomination is equal to 0. So let me fill in this other side. I think because we're trying to work out when it's going to run out. So 30025.83, 03 to the power of n minus this, and that's equal to 0. Okay. Now let's make it a bit more civilized. Looking like we want to put these two things together, get rid of those brackets. Now let's multiply everything by 0.03. So 30025.83 times 0.03. So this is going to change to 900.77. Yeah, cool. Okay, move the 2000 across. We get 2000 is equal to 900.77 times 1.03 to the power of n minus 2000.03 to the power of n. Okay, take a factor of 1.03 to the power of n. Get 900.77 minus 2000. Okay. So that inside is just equal to, so we got (2000) equals 1.03 to the power of n negative 1.1099.23. This. Can't take logarithms because we're going to end up with a negative. Maybe it was n minus 1. Yes, it is n minus 1. So if we go n minus 1 here, n minus 1 here, and then we change this to like that. Yes, I like this. I like this a lot more. And then it's going to give me the value that I need. Okay, so get rid of this guy, get rid of this guy, get rid of this guy. So it's going to be what? 3. So what did we say? 9. So 300. 25.83 times 0.03 times 1.03. So it's going to be 927.8 times 1.03 to the n minus 1. So 927.8 Tn minus 1, Tn minus 1. Yeah, and that's where we're going to get our value from. So minus 2000 equals negative 1072.2. Okay, we're going to divide. So 2000. So it's going to be negative 2000 on 1072.2. So 1.03 to the n minus 1. Okay, we're going to then take a logarithm of both sides. Doesn't really matter what it is in this case. Okay, so we get, no, we still have that negative on that side, which I don't want. N minus 1. Nah, it doesn't work. Okay, I'm giving up on that question. Too hard. Too hard. Move on. Okay, gave it an attempt, and the attempt was trash. The number of hours which light bulbs work failing can be modelled around a value x with cumulative distribution function. Jane sells light bulbs as promises they will work for the longer than exactly 99% of all light bulbs. Find how long, according to Jane's promise, a light bulb bought from her should work. Give your answer in hours, rounded to 2 decimal places. Is this one where we just substitute 0.99 into that? 1 minus e to the negative 0.01. Give your answer in hours rounded to 2 decimal places. Jane sells light bulbs and promises that they will work for longer than exactly 99% of all light bulbs. Find out according to Jane's promise light bulbs from her should The number of hours for which a light bulb will work before failing can be modelled by the random variable x. Okay, so this is what we're looking at here. So this thing is for all light bulbs. What she's saying is that hers can last for 99% longer than all of the light bulbs. So what we've got to do is we've got to look for when this here is equal to the 99% threshold. So we're going to have to integrate that, I think. So one minus e to the negative 0.01x dx. So to give us x minus or plus 0.01 e to the negative 0.01x. Now she's saying hers work 99% of the time. So we're wanting to look where the error is equal to 0.99. Actually, or is it just solving the equation? Cumulative function. Actually, I think it might be just the cumulative function you've got to solve. So you don't actually have to integrate it at all, I don't think. Because that just gives you a mess. So so she's saying that hers at 99%. 2.01x. So subtract 1, you get negative 0.01 to the negative e to the negative 0.01x. Okay, so it's just 0.01 is equal to e to the negative 0.01x. We'll take the log of both sides to get this. Okay, and then divides those sides by 0.01, so you get x is equal to log of 0.01 over negative 0.01. And hopefully this gives us something big. There you go. Somehow managed to bumble through that, but you know, can't complain. Definitely can't complain. By considering the equations of the tangents to y is equal to x squared minus 1, can I write something in the do not write area I've always wanted to? I think the reason why you're not meant to write there though, like it's just essentially saying, like that's where they cut the pages, so anything that you write there just gets lost. Like it's not so much a do not write here or you'll get, you know, scorned, it's more of a fact of don't write here, otherwise it won't be counted. Because you can see the little scissors here, just where it gets cut off when it goes to the scanner. Big guillotine slices it, you know. Considering the equation of the tangent to y is equal to x squared minus 1 at the point a squared minus 1, find the equation of the two tangents to y is equal to x squared minus 1, which pass through 3a. Find the equation of the two tangents that pass. Oh, okay, right. So the tangents that pass through that point, and there's going to be two of them. That makes more sense. Okay, so by considering the equation to the tangent at the point a squared minus 1. So that's just x, and then the function value at y. The equation of two tangents. Okay, well we've got a point. We just need a gradient, so let's find the derivative. So m is equal to, it's going to be 2x minus 1 at x is equal to 3. So my m value is 5. So the first tangent it's going to be what? Y minus or plus 8 is equal to 5 odds of x minus 3. So y is equal to 5x minus 15 minus 8. So that's one of them. Minus 23. What would the second equation be? Considering the equation of the tangent to y is equal to x squared minus 1. So, well, the equation itself, like what is it? It's a parabola, right? Y is equal to x squared minus 1. So it's a parabola that's down here. And it's saying we've got a point somewhere. So 3 minus 8 down here. Now, if I was to draw two tangents that go through that point there, it's going to be like a big one that comes like from like up here, and it's going to come down and hit it that way. The issue is, how do you get that second one? 5x minus 23. Okay, so it's like coming up from down here. So I've got the one that comes up from down there. I just need the negative one that's like hitting it from this way. Oh, it'll be the one that's perpendicular, of course, at that point. Of course. Of course, of course, of course. So second tangent. Or will it? Will it be the one that's perpendicular? Well, it may not necessarily be perpendicular. No, it doesn't necessarily have to be. Look at the gradient. Rise over run. I think this might be how you do it, okay? I'm not 100% sure though, so it's going to be 9 on 3 minus 2 on 3, which is equal to 7 on 3. So that's tangent number 2. So let's just throw it in and be done with it. So mx minus x1. So y is equal to it's just y minus 3 minus plus 8 equals 7 on 3 x minus 3. Oh, 3 and minus 3 is going to be good. Okay, so we get y plus 8 is equal to 7 on 3x minus 7. So y is equal to 7 on 3x plus 1. No, it's minus 8, isn't it? So plus 15 again. Oh, plus 15 minus 15. Just doesn't seem right. Oh well, whatever. Oh, it's a stupid question again. Alright, let's implement the cheat codes. Oh no, I said glitchless, so it's fine, we can't copy. Can't copy and paste. That's the glitchless. Alright, so I have to remember how to do this now. 97.5 was this guy. 175, and then the 160.6 was this one. The difference between the two. So the standard deviation is equal to 175 minus 160.6 over 3. Which is 4.8. So this is female 1. Oh, that was female 2, this is female 1. Okay, so 4.8. So if you add 4.8 onto 160, 6. What? 165, so it's 165.6. So therefore, mu is equal to 165.6. Sigma is equal to, so this is for female. And then the sigma is equal to 4.8. So for male, so it's plus 1.05, I think. 1.05 times that. So these are different sigmas and mu's. Obviously, it's not the same ones as up here, but 1.1 times 4.8. Okay, so now we know the male and the female. So a selected male is taller than 84%. So selected male. It's taller than 84%. So it's 1 standard deviation above. So it's going to be mu plus sigma, which is equal to 173.88. Should do 2's here. Plus 5.28, which is equal to 179.16. Okay, that one's done. People given a maximum. Okay, people given a maximum of 6 hours to complete a puzzle. The time spent on puzzle in hours can be modeled using a continuous random variable x. That's probably the density function it is. Graph show that a is equal to this. Show that a is equal greater than. don't actually understand what I'm meant to do. People are given a maximum of 6 hours to complete a puzzle. The time spent on the puzzle in hours can be modelled using a continuous random variable x, which the probability density function is this. The graph of the probability density function is shown below. The graph has a local maximum. Show that A is equal to that. So it's so much to go. Oh wait, no I don't. Oh, I'm almost done. Wow, that's pretty cool. People given a maximum of 6 hours to complete the puzzle. The time spent on this puzzle in hours can be modelled using the continuous random variable x, which is the probability density function. The graph of a probability density function is shown below. The graph of a local maximum. The graph has a local maximum. Do we have to find the local maximum? Show that A is equal to this. In relation to what? Like it's just an A in here, it's not equal to anything. Can we just integrate it and solve for A? Is that something we can do? Show that the modus of x is equal to 2. I think you just differentiate this, don't you? So I need to find what A is first. So A, to show that A is equal to this. I think you do have to integrate it, because I'm looking at this bottom line and it looks like it's the derivative of the top line in some way, shape or form. But what do you do with the A? Show that A is equal to this. How? Well, why? So, showing A is equal to this. If I substitute that into this, what does that do for me? It gives me 2 log 10 of x squared plus 4. Times x squared plus 4. That's just integration. From 0 to 2, yeah, I know that bit. Show that A is equal to 2 log 10, and they don't give you an equation to solve. F of x is equal to this. Are we looking for the derivative? Like, is A the... No, let's stuff it. Let's try it. So f of x is equal to this. Ax on x squared plus 4. So the derivative is the quotient rule. So u is equal to ax, u dash is equal to a, v is equal to x squared plus 4, so v dash is equal to 2x. Okay, so I've got to get this right way around. It's v dash u minus u v dash, v dash u minus u v dash. My v's are in the middle. V u dash minus u v dash. b squared. And equate, oh, of course. I was trying to work out what you'd make it equal to, but because it's a probability density function, hey, it's got to be equal to 1 underneath the curve. That's what it is. That's what it is. That's what it is. That's what it is. Silly, silly, silly. You can tell it's been a long, long time since I've done this. Yeah, that makes so much sense now that I think about it. I thought it was integration, but just couldn't work out what you would make it equal to, but that makes so much sense. And that's why the logarithm appears on the bottom. Thank you for your help, Mike. X squared plus 4 dx. Okay, so pull the a out the front. We don't need him at the moment because he's just a constant. Okay, take that. So we need 2. So we need a 2. So we can say a on 2. 2x on x squared plus 4, like this. Okay, and then that gives us our a on 2. It's going to be log of x squared plus 4, I think. Because it's the function at the bottom. Yeah, cool. Okay, now because density function, between 0 and 6, isn't it? So, boop, boop. Density function f of x dx must be equal to 1. So 1 is equal to, and then we can do this bit. So a on 2. And we can do that. Actually, we don't need him. And it's going to be, so it's going to be log 6 squared. Oh, because I've got the square on the inside. Oh, no, it works out, log of 6 squared, 36, so 40. Minus log of 4. So 1 is equal to a on 2 log of 10. So times by 2, divide by log of 10 to get a. That was the one little piece I was missing, is that as a probability density function, it should be equal to 1. Show that the mode of x is 2 hours. The mode of x is 2 hours. That's the value, the highest point. So we're looking for the maximum turning point there. So the maximum turning. So we're essentially looking for this value, this height here. So where it's turning around. So substitute this back into this guy here. So ax on x squared plus 4, I think it was. And where a was equal to ln of 10 on 2. Was it that way or was it the other way? It was the other way. Okay, so 2 on. Oh, see ya. Defeated by the computer. Oh, hey, it's come back. Didn't know what to do. Okay, just get the eraser out. 2 on ln for 10. Okay, yeah, okay. So we're looking for when the derivative of this now is equal to 0. So we're looking for when dy dx is equal to 0. And we've got 2x on so basically all that working out I did before was for this one because we're looking for that highest value, that minimum turning point, maximum turning point, that stationary point. You can just leave it as that, we can substitute it in once we're done. So u, v, u dash, v dash. U is a x, u dash is a, v is x squared plus 4, v dash is 2x. Okay, so dy dx is equal to uv dash minus vu dash. No, that's the wrong way. Vu dash. V dash u minus uv dash. No, still wrong. Vu dash minus uv dash. V squared. Okay. So v is x squared plus 4. U dash is a. U is ax. V dash is 2x. For v squared, so x squared plus 4. So we're essentially looking for when this thing is equal to 0. So let's put it all together. Because a is just a constant, we don't really care too much about what it is. But we can factor it out and get x squared plus 4 minus 2x squared over, and we don't care about this bottom line really either. So we've got a lots of 4 minus x squared over x squared plus 4. Now dy dx is equal to 0 when 4 minus x squared is equal to 0. Only that part, when only that part's equal to 0. So we get x squared is equal to 4, so x must be equal to plus or minus 2. Okay, so therefore, since negative 2 not in domain, 2 must be the mode. Cool. Happy days. Now show that the p when x is less than 2 is equal to log 10 of 2. Now I feel like you just have to integrate that again, but from 0 to 2, so it's basically this line again. But with a obviously substituted in. So 2 log of, so I'm going to go from this line here. So a on 2 a on 2, I don't log just yet. Yes, I do actually. Log of x squared plus 4. Okay, you can probably substitute a in now, since a is 2 on log 10. And 2, lots of log of, it's going to be, what, 8 minus log of 4. 2's cancel. So log 4 on log 10. Plus 2 that work. Oh, it's division, isn't it? It's not takeaway. Which is the same as, it's just a change of base, isn't it? So log base 10 of 2. Cool. That works out. Normally is treated with a mean of 100 and standard deviation of 15. It has been observed that the puzzle is generally completed more quickly by people with a high IQ. It is known that 80% of people with an IQ greater than 130 complete the puzzle in less than 2 hours. Person chose a random complete puzzle in less than 2 hours with a probability. So it sounds like a. It just sounds like a bloody conditional probability question. Nothing about the other thing. It's been observed that greater than 130. So okay, so people who so let's make a two-way table. So this is people. Okay, people IQ. Actually. So, solves in 2 hours, or less than 2 hours, and IQ greater than 130. We'll work backwards. We'll work backwards. So, this is going to be less than 2 hours. So less than 2, greater than 2. Oh, I've done it the wrong way up here anyway. So less than 2, greater. Keep doing it the wrong way. Less than 2, greater than 2. And then it's less than, or greater than 130. I've completely done this the wrong way. Greater than 130. Get rid of this absolutely abomination up here and over here. Okay. So, we know that 80% of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. So greater than 30, IQ is 0.8. Oh, hang on. It is known that people with a greater IQ than 130 can complete the puzzle in less than 2 hours. Oh, okay. Okay, so probability that the IQ, so 2 hours, given that their IQ was 130, is equal to 0.8. I think we need a two-way table for this after all. Okay, so the probability of someone having an IQ of 130, what's that? So it's 2 standard deviations away. So 2 standard deviations, so it's going to be, what? So 64, so it's 95, so 97.5. So 97.5%. So 0.975. So okay, so it's known that 80% of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. So what is the probability the person has an IQ of 130 given the answer corrected to 3 decimal places? Person chosen around who can complete a puzzle in less than 2 hours. So people who can complete a puzzle in less than 2 hours. Do we have a number? Do we have a number that's for the people less than 2 hours? Number for the people less than 2 hours. I don't think we do. %, of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. So 80%. I think it's just this number multiplied by 0.975. I think it's just the two numbers multiplied by each other. So 80% of people finish it. Oh wait, actually. So probably that someone is greater is going to be... So it's going to be 1 minus this. So it's going to be equal to 0.27225. Okay, no, 0.25. Okay, so of the 80% who finished the puzzle in less than 2 hours, no, hang on, it's 80% of people with IQ of... Okay, person is chosen at random who can complete the puzzle in less than 2 hours. Okay, so that's already set. So it doesn't matter what it is, it's just 80%. Because, okay, so less than 2 hours has two groups, right? It's got the greater than 130 IQ, which is 80%, and it's got the less than 130 IQ, which is 20%. So this step has already been done. Like the less than 2 hours. Like you've already picked someone who can pick less than 2 hours. So it's just 80%, isn't it? P of IQ greater than 130 given that x is less than 2 is equal to probability x is less than 2 given the IQ is greater than 130 times the probability of IQ is greater than 130 divided by the probability of x is less than 2. Let me write that down. Probability of A given B is equal to probability of B given A times the probability of A over the probability of B. Do we know all those values though? So 0.8 times 0.025 log 10 of 2. Ah, because we integrated up to that point here. Yes. Yes. So then your 0.8 is your probability that they're finished. Because I want it the other way around, don't I? Person random chosen puzzle is less than... What is the probability that the IQ is greater than 130 is known... So yeah, so the probability, so if A is, if we let A be equal to what? The IQ is greater than 130 and B be equal to times less than 2 hours. So it's probability of A and B times, so then it's going to be the 0.8 times, so the probability of A, which is 0.025, which we found, over the probability so that up to that point, so that a value. Yes, okay, of course. So which is your log 2 base 10. Right? Yeah, okay. I feel like... Zero, 006, 02, blah, 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 is what I've got on here. Log 2 base 10. It's log 2 base 10, wasn't it? I feel like it was. No, log 10 base 2, I got it the wrong way around. Yeah, that's better. Okay, let's get going. Let's keep pushing. Last question, cool. Alright, a discrete random variable has probability distribution as shown in the table where n is a finite positive integer. Show that e of x is equal to n minus, so the expected value. Okay, so it's just it's just words. So we just do this times this. Okay, now and then add on. So it's going to be r times rn plus r squared times rn minus 1 plus r cubed times rn minus 2 plus up to Rn times R. Now, this is our expected value. Pretty straightforward stuff. That part, at least anyway. So R to the n plus 1 plus R to the n plus 1 plus R to the n plus 1 plus up to R to the n plus 1. So we're going to be doing that R to the n times, I think. Yes, because it goes up to R to the n. And it starts at r to the 1. So, we have this n times. So this is n to the rn plus 1 times, if you add them all up. So like, you know, first two is 2, then 3, and 4. Discrete distribution where n is a finite positive integer. So I think actually what we could do if we take this, we could do a sum of the. No, I can't be equal to 1. I think going. It's not arithmetic. Well, I suppose we are adding 0 each time. So let's call it an arithmetic sequence of n terms. So the sum of this then is going to be equal to n over 2 a plus l, right? Or do we want to go the other way? I think we want to go the other one. 2a plus n minus 1 times the difference. Now in this case, the difference is equal to 0 because you're not adding, like you're adding the same value on each time. You're not increasing it as you go up. So you can just treat this like an arithmetic sequence or series, right? Because it's going up by the same value. We don't want to treat it as a geometric series because we don't want the r value to be equal to 1, which it would be in this case because it's going up like you're multiplying by 1. But let's treat it as if we're adding 0 to each of these sequences, or to each of these numbers in this sequence. So d is equal to 0, the difference. Our a value, our value start with is r to the n plus 1. Our n is just n. Okay, let's try this. Let's see what happens. So n over 2 times 2 lots of, it's just going to do the same as before, plus n minus 1 times 0. It just gives me the same thing as before. Show that e dx is equal to n 2r minus 1. Then you make a geometric series as Rn down to r is equal to 1, so x r. Because you're changing by r each time in the top and the bottom. Let me think. If you're doing the mean, expected value. Expected value is just the mean divided by the number of terms, isn't it? Oh, yeah, of course. And from here, yeah, so if you think about expected value, like if your expected value is just the... Hang on. I've got a way that I can finish this off with my way. The expected value is just the mean times the probabilities, isn't it? There's another way you can do it. Expected value is just the mean. Because when you find the mean, you do the top times the bottom. Then you make a geometric series as Rn plus Rn minus 1 plus up to r is equal to 1. So that's the bottom line, isn't it? So r times 1 minus m over 1 minus r is equal to 1. I'm trying to follow along with you, Mike, but I think my brain is just absolutely fried at the moment. To the point where, like, it's just all jumble for me. And I do appreciate you trying to help. I don't think I just can get my head around this at the moment. I'd actually have to sit down and think about it properly in a not time-constrained manner. What am I missing? It equals 1. Oh, of course it is, because it's a bloody... Okay, I see what you mean now. I see what you mean now, because it's a bloody geometry. It has to be equal to 1, doesn't it? So... this guy here has to be equal to 1, right? This sum? No, that's the expected value. The expected value doesn't have to be equal to 1. This bottom line has to be equal to 1, so you can do a sum of that and then work it out for n. Okay, I think I've got it. Let's delete some stuff. Okay, because the probabilities have to add up to 1, otherwise it doesn't work. I hate probability. Give me just proper calculus, I reckon. So you've got Rn plus Rn minus 1 plus R to the n minus 2 plus down to R is equal to 1. Now this is a geometric series, right? So it's a geometric series because you're dividing by R each time, or times it by R. So the difference in this case, we use difference, so it's a ratio. The R value in this case, our R value is equal to 1 on, well, it's 1 on R this time. So our R is equal to 1 on R. Okay. Now our first value, our A value, is equal to R to the n. And it's a geometric series that has a finite end. So R to the n, 1 minus R to the n over... I don't think it really matters which way I go with this one. 1 minus R. Okay. And then this guy has to be equal to 1, right? So you get R to the n, 1 minus R to the n is equal to 1 minus R. So R to the n minus R to the 2n is equal to 1 minus R. Oh, excuse me. You know what, I'm going to call that one there. I've actually given it an attempt. We've given it an attempt. It stumped me. It stumped me. At least, and remember, this is, after all, the any percent. So, I'm just going to call it there for that one. Whilst I go get myself a drink and we stumble into part 2, 3. I'm not looking forward to this next bit. Alright, let's go. At least it's only a 2-hour exam. Okay, this one's going to be a bit different because I'm going to have to do it on the side. With that being said, I'll be back in a sec, whilst I'll just quickly... Alright, let's do this last exam, get it over and done with. Okay, so I've already shot myself short quite a bit of time. Just need something to relax my throat a bit. Alright, so as I was saying, this one's going to be a bit different because I don't give you space to answer the questions, but that's fine. I'll zoom it in anyhow. For the multiple choice at least. Okay, so first one, given that OP is equal to -3, 1, and OQ is equal to that, what is PQ? So from O to P, it will be more like this, I guess. Oh, I don't like that. So from O to P, it's 1, -3, so it's like this. So it's P, O to Q is 2, 1, 2, 3, 4, 5, something like this. And what is from P to Q? So we are going to be adding them? No, that can't be right. Jeez, I can't remember how to do vectors. Wow, that's probably not a good sign. OP to OQ. So just the difference in the two. Well, it probably helps if I actually draw this picture properly and actually have it the right way around. I don't know what the hell I did that for. -3, 1, it's over here. So that's P, and Q goes 2 and 5 like that. I'm so bloody confused. Okay. So, our thing looks something like that. So that is P take away Q, or Q take away P. In this case, okay. So 2, 5 take away -3, 1. I'm hoping there's a solution that says this. I know I did a fraction. Hey, we got there. Cool. Alright, oh, that's gross. Which of the following is the integral is equivalent to this? There's one similar. So if you differentiate sine squared of 3x, or sine 3x squared, I should say. So if you differentiate this, so you got this is equal to, so this would be, so you bring the derivative out the front, and you multiply by the power. So it's going to be times 2 cos squared 3x, like that, I think. So let me write it like this. I think this one might help a bit more. So you got sine squared 3x. Just literally write the same thing. Okay. So if I was to differentiate this, what you would get is you'd bring the derivative of the inside to the outside. So the derivative of sine 3x is 3 cos 3x. You'd also bring this guy down, and then you would write down the original equation again. Like that. Okay, so that's if you had a polynomial. So derivative inside outside, power down, subtract 1, and subtract 1 as well. So it'd become 1. So doing the reverse of that, so you're dividing by the power. So you divide by the old power, so the 2, and add 1 to the power. Why haven't they added 1 to the power? I don't know. Can I just quit already? Bang! Well, it's going to be cos. It's going to be negative cos. Yeah? That sound right? Sine squared 3x is the same as 1 minus cos squared 3x. 1 minus cos squared 3x. It's also the same as... I don't friggin' know. I'm going to skip that one. What is the remainder when that is divided by that? Oh, that's annoying. We can do this though. Minus 2 cubed, minus 2... Jeez, it's been so long since I've done extension stuff. I thought the bloody advanced stuff would be bad. This is so much worse. So 8 minus... Well, it's 4, so it's going to be minus 8. So cancel out. It's going to be 6, and it's going to be 8, so it's 14. So long. Consider the DE. That which of the following equations best represents this relationship between x and y. So you got y dy is equal to x dx. We're going to integrate both sides, and we're going to get y squared plus c is equal to, well, it doesn't really matter. Y squared is equal to x squared plus some constant value c. Forgetting how to integrate simple things. So we get y squared is equal to 2x squared on 2. Yeah, okay. So they just cancel that. So y squared is equal to x squared plus some constant c. Oh, I love the little shortcuts for those DEs. No, it's known that... So for the two vectors, it's known that the dot product is less than 0. Which of the following statements must be true? So dot product again. No, it's this one. The angle must be obtuse. I think that's true. Because when they're perpendicular, the dot product is equal to 0. When they're close together, when they're acute, so I think it's when it's obtuse. The product is, no, it's not necessarily true, and it's definitely not when they're collinear. I think when they're I don't know what the dot product is when they're collinear. It doesn't exist or something, I don't know. The random variable x represents the number of successes of 10 independent Bernoulli trials. Probability of success is 0.9 of each trial. Let R be equal to probability that X is greater than 1. Which of the following describes the value of R? 10 independent trials. Probability of success is equal to 0.9. X is greater than or equal to 1. X is greater than or equal to 1. Probability that X is greater than or equal to 1. So it's the probabilities. So it's the probabilities that it works, right? The probability that the event occurs. Okay. So probability is greater than 1. So which best describes the value of R? Oh, it's gonna be C then. It's gonna be between them. Yep. Okay, that makes sense now. But I think about it, because if you think about it, if you do think about it, hi mouse. So if you think about it, so 0.9 probability of 1 occurring. Okay, so it has to be less than 0.9, because it's gonna it's saying 1 occurs, like 1 happens. Chance of 0.9. So anything bigger than 1, well, that probability is going to go down. Not by much, but it is. And then, the fact that it's going to fail all the times, it's going to have to be bigger than 0.1. A lot bigger than 0.1. So I think that's correct for that one. Okay, anyway, let's move on. So which curve best represents the graph of the function f of x is equal to negative a sine x plus b cos x, given that constants a and b are both positive? I don't friggin' know. I feel like I've got some things that might help me with that. Okay, so negative a sine x, negative a sine x, negative a sine x. Maybe I don't have things that can help me with that. Okay, let me think about it. So, which curve best represents the graph of a function f of x equals negative a sine x plus b cos x. Negative a sine x plus b cos x. Negative a sine x plus b cos x. I don't actually know. Alright, skipping that one as well. I'm really bad at extension. So what, is that 2 questions I've skipped? Yeah, it is, and they're both trig questions. I hate trigonometry, I've come to learn. Alright, which pair of parametric equations represents a semicircle is shown? It's more trig. Cool, I love trig so much. Okay, so it's the bottom half of the semicircle, so it's going to be from negative 2 pi to pi and 2 to pi 2. Okay, cool, we've got that. I'm glad we've established that. Now, Radius is 1. Just try something. X squared plus y squared. So what do we get? We get 3 plus... Nah, that's not going to work for me. I really hate trigonometry, I've come to learn. Parametric equations too. Never seen a semicircle represented as a parametric equation. It's 3, 2. So x is -3. Y is -2. So it's going to be A. I just realized what to do. So this is your first bit here. And it's radius 1, 2. So yeah, this works. So your other equation, y is equal to 2 plus cos t. So y is equal to... Oh, sorry. So y minus 2 is equal to cos t. And then you square both. So square, and then add them together. So you get x minus 3 squared plus y minus 2 squared. So that's your radius. So x plus 3. So 3 across 2 up. And then it's equal to sine squared plus cos squared, which is just equal to 1. So yeah, that works out. Which graph represents the function y is equal to sine? Oh, I don't know what those are. I think, though, I can work out pretty quickly that it's just C. I'm pretty sure it's C, and that's my guess. That's what I'm going with. Yes, Lane, still going. Still got a long time to go. The members of a club voted for a new president. There were 15 candidates for the position of president, and 3,543 members voted. Each member voted for one candidate only. One candidate received more votes than anyone else, so became the new president. What's the smallest number the new president could have received? Pigeonhole principle. So 3, 5, 4, 3 divide 15. So you would have had to have 237 votes, because 236.86, he must hit that other one. So if they all got 236 votes, then he must have at least got 237 to have the minimum. Okay. So this is the part where it gets annoying, and I'm going to have to do this. Because you're meant to have a writing paper when you do this. I do not have writing paper. So I'm going to do mine on the side. Okay, so A, so find the sum of these two vectors. So it's just 3i minus j. Expand and simplify. Okay, so it's going to be... So that one is going to be pretty much just your typical Pascal expansion. So it's going to be so 4, so 1, 4, 6, 4, 1. I believe so. It's 1 times 2a to the power of 4 times b to the power of 4, negative b to the power of 4, plus 4 times 2a to the power of 3, negative b to the power of 2, 0, sorry, 0, so 1, plus 6, lots of 2a to the power of 2, b to the power of 2 plus 4 lots of 2a to the power of 1 negative b to the power of 3 plus 1 lot of 2a to the power of 0 negative b to the power of 4. So this is going to be 16a to the power of 4 plus, well, it's going to be negative actually, negative, so 2, 4, 8, 8, 16, 24, 32, a cubed b, and then it's going to be plus, so it's going to be plus 6, 4, so 8, 6, 12, 18, 24, a squared b squared, minus 8ab cubed, plus finally, because the b to the power of 4, so negative b to the power of 4 times. Okay, so that's b done. Use the substitution u is equal to x plus 1 to find that. So u is equal to x plus 1 to find x root x plus 1 dx. Okay, so firstly, we need to make our substitutions. So I need to start off by rearranging this. So x is equal to u minus 1. So dx du is equal to 1. So dx is equal to du. I think I could have done it either way, to be honest. Du dx. Okay, now we have u is equal to x plus 1. So we can substitute this guy into here. And we get u minus 1, okay, which is our x value from down here, times the square root of u. And that's just going to be du. Okay, so now we integrate this. Now, how do we, so this is going to be the same as u, 3 on 2, so integral of u on 3 2 minus u to the half du. So this is going to be equal to, okay, so divide by the, so subtract 1 from the power, so bring the power down. So add 1 to the power, divide by the new power. So it's going to be 2 on 5, u to the 5 on 2, minus 2 on 3, u to the 3 on 2. And there we go, so that's basically it. Okay, do your committee. I'm just going to keep going down, I think. So D, a committee containing 5 men and 3 women to be formed in groups from 10 men and 5. How many different ways can the committee be formed? So you've got 10 men to choose from, so it's going to be 10 choose 5. We'll do it this way, so we don't get confused with vectors. 10 choose 5. And you're going to multiply that by all the possible combinations of the 3 women. So 8 choose 3. I believe that's a choose one. 10 choose 5 times 8 choose 3. And so you can have 14,112 different combinations. Spherical bubble is moving up through liquid. As it rises, the bubble gets bigger and the radius increases at the rate of 0.2 millimeters per second. At what rate of the volume of the bubble increasing when the radius reaches 0.6 millimeters? Express your answer in millimeter cubed per second. So a spherical bubble is moving through a liquid. As it rises, the bubble gets bigger and the radius increases at a rate of 0.2 millimeters per second. So radius So dr dt is equal to 0.2 millimeters per second. What is the volume of the bubble increasing when it reaches 0.6 millimeters? So dv dt question mark. And so the thing that links dv dt and dr dt is dr dv dr. So r, so the volume in this case, so it's a sphere, so 4 and 3 pi r cubed. So dv dr is going to be equal to 4 pi r squared. Okay, so to find dv dt, we're going to do dv dr times dr dt, and that's going to give me what's it going to give? It's going to give us 4 pi r squared times 0.2, and then at r is equal to, what value was it? At r is equal to 0.6. So this, so 4 times pi times 0.6 squared times 0.2. And this is the rate of the sphere at that time. Where's my calculator down here? So 4 pi, so it's 0.6 squared times 0.2. So the rate at which the volume is growing is 0.9048 millimeters per second cubed. Millimeters cubed per second, sorry. Okay, cool. F, evaluate that gross integral. Okay, I'm gonna have to probably do it over here, just save some space. So I might pull up this actually. There we go. Extension, yarn exam. That's 2021, 2021, please. Like I... Oh, nice. Let me just check something really quick. No, I don't have it. Okay, that's fine. Okay, so while that loads, let's have a look at the question again. So it's from 0 to root 3. Okay. My exam is loaded. From 0 to root 3 of 1 on 4 minus x squared dx. Okay, I suspect this is actually a one that they give you. It is. So we've got it of the form of this. Right. Because we can rewrite this as this, yeah? So this guy here is going to be equal to the inverse sine of f of x over a. So f of x, so just x, over 2 plus our constant c, which we don't care about because it's doing from 0 to root 3. So we're essentially looking for when we have the inverse sign of root 3 on 2 minus the inverse sign of 0. So that cancels out because it's equal to 0 and sign is equal to 0. Root 3 on 2 is pi on 3. So yeah. Cool. So it was f, g by factorizing or otherwise. Solve this equals 0. By factorizing or otherwise. By factorizing or otherwise. F, G. So the equation is 2 sine cubed x plus 2 sine squared x plus or minus sine x minus 1 is equal to 0. By factorizing or otherwise? How do you factorize that? I suppose you look at the first bit and take 2 sine squared out. And that would leave you with sine x plus 1 minus sine x plus 1 is equal to 0. Like that. So that gives you sine x plus 1, 2 sine squared x minus 1 is equal to 0. So now you're just solving these two things, like next to each other, I guess. So we're looking for when sine x plus 1 is equal to 0, or when 2 sine squared x minus 1 is equal to 0. And the domain they give is between that. Okay, so we've got sine of x is equal to -1. So x must be equal to, so when sine of x is equal to -1, so think about your unit circle. So start this way. Sine 0 is sine 1, sine 0, sine -1. So x must be equal to 3 pi on 2. Now this side, so sine squared x is equal to a half. And then so sine x must be equal to plus or minus 1 on root 2. Or root 2 on 2. Okay, so when's it equal to plus or minus root 2 on 2? So that must be when x is equal to, now that's pi on 4. So it's equal to pi on 4. So therefore x is equal to 3 pi on 2, pi on 4. Okay, so pi on 4, 7 pi on 4? No, that's too much. 3 pi on 4? 5 pi on 4? Yep, it's 7 pi on 4. Cool, and so that's the solution to that one. Okay, so we've got the roots of x to the power of 4 minus 3x plus 6. This, and this. What's the value of that? Oh, okay. GH. Okay, just to write it out again. So x to the 4 minus 3x. 6 equals 0. Roots are alpha, beta, gamma, and delta. Okay, so well, we need to find what? 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta is. So how are we going to go about this? So we need to use the roots, essentially, the roots of the thingo, and do a combination of them to get what we want. So that's equal to negative b on a. So let's start off with our, so a is equal to 1, b is equal to 0, c is equal to 0, d is equal to negative 3, and e is equal to 6. So those are the 5 roots, because it's like, 0x cubed plus 0x squared. Hang on. Yeah, plus 0x squared plus minus 3x plus 0. So those are the roots. So I need to combine them to get the thingos on the bottom. So how am I going to do that? Okay, so that's the combinations. So how can I add these together to get what I want? How can I add these together to get what I want? I think can you divide them? Can you multiply them? I'm thinking if I divide the first one by the second one. So the first one, well, I don't want to use the first or the second one because it's just 0 divided by 0. So I'm gonna have to use, oh no, not necessarily. Wait, yeah. So probably something with the, oh, we could do 3 divided by 4. So 3 divided by 4, let's try that. So alpha, beta, gamma, plus alpha, beta, oops, delta, plus beta, gamma, delta. That's missing one though. Have I done all of those ones? ABY, ABD, BYD, 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 BYD. That doesn't give me enough though. Alpha delta. So that give me delta. Alpha beta delta. That give me gamma. Delta what to delta? I feel like I'm missing one from that line. Alpha beta gamma. Alpha beta delta. Delta. Okay, let me just try this and I'll see which one I'm missing. alpha, beta, delta, gamma delta. Okay, so BBY, so if there's 1 over delta here, plus ABY, AB delta, so 1 over gamma, plus BY delta, so BY delta. Oh, we're missing the one with the delta. So there should be also alpha, gamma, delta, alpha, gamma, delta. Yeah. It's 1 over beta. Cool. Okay. Which is equal to, okay, cool. So which is equal to negative D. D on A divided by negative, or positive E on A. So negative D on A. So A is just 1. So negative D is 3. So 3 divided by 6. So it's equal to half. Okay, that's pretty cool. We like that. We like those ones that are nice and easy. In that sense. Okay, is that question 11 already done? That'd be pretty cool. Hello, Mousy. Mousy! Okay, question 12, cool. What a mess. This is so dumb. Use a different booklet. Okay. Okay. The direction field on the differential equation is given on page 1 of the question 12 writing booklet. Oh, there are actually writing booklets. That's pretty cool. Maybe I should use them. Okay, there it is. Cool. Sketch the graph of the particular solution that passes through the point P, and point P is on there. On the diagram provided in the writing booklet, sketch the graph of the particular solution. Oh, that's really easy. Okay. So P goes through here. Just like that. There you go. That's your differential equation that goes through that point. So you just basically follow the lines around. Cool. Okay, 12 part B. Oh, there's only worth 1 mark, that's cool. A bottle of water with temperature 5 degrees Celsius is placed on a table in a room. The temperature of the room remains constant at 25 degrees Celsius. After T minutes, the temperature of the water in degrees Celsius is T. Do not prove this. Okay, so let's go after 8 minutes, the temperature of the water is 10 degrees Celsius. By solving the differential equation, find the value of T for which the temperature... Okay, that's easy. So... A part 1... Oh, this is B part 1, isn't it? Okay, so we've got this... The temperature of the water is 10 degrees Celsius. Solving the differential equation. Okay, so we basically just have to integrate that, I think. Maybe? There's no T in there though. It's a big T, but not a little T. After 8 minutes, the temperature of the water is 10 degrees Celsius. By solving the differential equation, find the value of T when the temperature of the water reaches 20 degrees Celsius. In units to nearest minute. After 8 minutes, the temperature of the water is 10 degrees Celsius. By solving the differential equation, find the value of T when the temperature of the water is... So I'm presuming I'm going to have to do something like this. So dt is equal to kt minus 25 dt, right? And I'm going to bring this guy over. So we got dt on this side, t minus 25 is equal to k dt. Now if I integrate both of these sides, so this is the same as 1 on t minus 25 is equal to k dt. That's a little t, isn't it? This is going to give us, so this is just ln of t minus 25, which is equal to kt plus c. Now we have to think through terms of time. So at t is equal to 8 minutes, the temperature is equal to 10 degrees Celsius. Do we know what it starts at? Degrees Celsius. Okay, so at 0 we've got that, and at t we've got that. So we can work out our k value using these guys here. So, let's actually continue solving this for t. So e to the ln of t minus 25 equals e to the kt plus c. Because we need to solve for the constant term c as well. So t minus 25 is equal to this. And so t is equal to 25 plus kt plus c. Plus our constant c up there. Okay, and this is how we find our constant. Okay, so e to the kt, so e to the 0 plus c to c here. So take logs of both sides, so log of a fifth is equal to c. Work out what our k value is. We're just finding the equation. Kinda. Okay, so we found that bit there. So now we've got t is equal to 25 plus e to the kt plus log of a fifth. So now we do this bit here. So this one. Okay, so now we do the second one. So t is equal to 8, we've got 10. So 10 is equal to 25 plus e to the 8k plus log of 1 on 5. So it's going to be 2/5 now. Is equal to e. So we'll take the logarithm on both sides here. minus that, so it's going to be ln of 2 on 5 minus 1 on 5. I think minus, no, you divide when you minus. Equals 8k, so k is just going to be equal to, so it's going to be the same as 5 on 1 times, that cancels with that, so it's ln 2. So k is equal to whatever that is. We'll just leave it in whole form. Okay, so now we've got our equation. Our equation is t is equal to 25 plus e to the ln 2 on 8, t plus ln of a fifth. Okay, now at, please don't tell me if this solve t, how much should we do? Find the value of t when the temperature is 20 degrees, so at t equals 20 degrees Celsius. So 4/5 this time is equal to, that ln goes up the top of this. So 4/5 is equal to, and it's going to be the log of 4/5 is equal to ln 2 on 8 t plus ln of a fifth. So same deal, we're going to get ln of 4 is equal to ln of 2, 8 t. So we get 8. We're dividing. We are dividing, so 8 ln 4 on ln 2 is equal to t. So whatever that disgusting value is what our solution should be. It gives us a nice number of 16 for some reason. Cool, okay. So how much space have I wasted doing that? A bit. Okay, sketch the graph of t as a function of t. Oh Christ. Okay, let's just do it here. So t is equal to 25 plus e to the ln 8, 2 on 8. T plus ln of a fifth. I don't know how to draw that, to be honest. Well, it's only a 1 marker, so I guess we can do some dodgy stuff. Okay, so at t is equal to 0, we had 5 degrees. 5, 10, 15, 20, 25, 30. Six, 4, 6, 8, 10, 12, 14, 16, 18. At 8 it's 10. And at 16, I think it was 20, wasn't it? At 16, it was 20. This is going to be like a... something like that. That'll do. Oh, cool. Induction. Alright, get that memorized in your head. So this is part C. So use induction, so 1 times 2 times 3 plus 1 over 2 times 3 plus 4 plus up to quarter minus 1 on okay, so step 1. Step prove for n is equal to 1. So 1 over 1 times 2 times 3 is equal to quarter minus 1 over 2 times 3 times 4. So this is 1 over 6 is equal to a quarter minus 8, 16, 24. So 1 over 24 is the same as 6 over 24. No, sorry. Got that right? 2 times... Oh, it's 2 times 2 times 3. So 6, 12. That's what that's meant to be. So it's 3 over 12. Gives us 2 over 12, which is equal to 1 and 6. So we're happy. Okay, so step 1's done. Step 2. Assume... I have brain to do more maths. Yeah, I definitely do. Assume true for n is equal to k. So that is 1 over 2 times 3 times 1 times 2 times 3. It's 1 over 2 times 3 times 4 up to k times k plus 1 times k plus 2 is equal to, so this is the fun bit, quarter minus 1 over so we're assuming that's true, okay, assumption made. Now prove for n is equal to k plus 1. So 1 over, so i.e. in other words, times 2 times 3 plus 1 over 1, 2 times 3 times 4 plus 1 over k plus 1, k plus 2 plus 1 over, and then this is the important bit, k plus 1, k plus 2, k plus 3 is equal to a quarter minus 1 over 2, and I'm going to just write it as this, 2k plus 2, k plus 3. Okay. So we know that this guy here, all this stuff in here is just equal to this. So we're going to replace that, so it's going to be a quarter minus, so we go, well, left-hand side. We'll start with left-hand side. So that 1 minus 2k plus 1, k plus 2, plus 1 over k plus 1, k plus 2, k plus 3. This is equal to, okay, let's expand and simplify. 1 over This would be 2 lots of k squared plus 4k plus 2k plus 4 plus 1 over k squared plus 2k plus k plus 2 k plus 3, which is equal to quarter minus 1 over 2k squared plus 6k plus 4 plus 1 over k cubed plus 3k squared plus 2k squared plus 6k plus k squared plus 3k. Oh, I should have added those up, whatever. Plus 6, 2k plus 6 equals a quarter minus I'm just going to leave that as it is for now, I think, until I work out what I want to do with it. But this thing I want to simplify a lot. Okay, so no more k cubes. Plus 6k squared. 9k, 10, 11k. I feel like I'm missing something from there. K cubed. 3k squared. No, I've got 8 terms. Yeah, no, that's the right amount. I might just double check though. K cubed, 3k squared, 2k squared, 6k, k squared, 3k, 2k, 6. Yeah, okay, that's fine. Okay. I feel like it'd have been easier to start with the right hand side and move to the left hand side, but you know. I'm a sucker for punishment. Okay, let's put these together now. So we'll start off with the first two. So 2k squared plus 6k plus 4 over minus 4 over I'm not looking forward to putting those two together. simplify this a bit then. So k plus 3. Two numbers that multiply to give 3 and add to give 2. Multiply to give 2, add to give 3, 2 and 1. Oh, that's not a number I didn't want to hear though. Okay, if this doesn't work, I'm just going to skip it. I feel like this is so wrong if I need so much bloody space. K plus 3. I give up. That's a joke. It's a joke. I don't know what I'm doing. Like, everything seems sound, but I just... Can I go the other way? Can I factorize these actually? Let's start. Two numbers that add to 4. So that's going to be what? 2k plus 6, 2 and 3. Yeah, okay, I give up. I'm not wasting any more time on that. I've had serious attempts. Now I feel absolutely gross. It was disgusting. I feel like I've done something. I did something like small somewhere and it's completely screwed it all up. I'm gonna move on. Alright, so we've got an hour and a half. We're almost finished part 2. Question 12. 2 more parts to go after that. The function is defined by this for the domain from negative infinity to 2. Sketch the graph showing the x and y intercepts. Okay, so it's a parabola that's been shifted. So let me think. It's also mirrored in the y, so like the whole thing flips around and it's 1 to the left, I think. Left, I think, and then the whole thing is negated. Oh my god, this is actually so dumb. Well, let's do the inverse function. Inverse function's easy. I'll come back to it in a sec. So the inverse function. So the idea behind the inverse function is you make x be, you swap x and y around. So 4 minus, and then you go 1 minus y on 2 squared. Yep. Okay. So this is what. So we'll get x minus 4 is equal to negative. So if we go 4 minus x is equal to 1 minus y on 2 all squared, like that. Take the square root, we get 4 minus x is equal to 1 minus y on 2. Subtract 1, we get root 4 minus x. Minus 1 is equal to minus y on 2. So then we're going to get 2 minus 2 lots of 4 minus x is equal to y. Therefore y is equal to 2 minus 2, 4 minus x. And sketching the graph, well the graph is just the so if I know the graph of the first one, I can graph the second one because it's just a all the x becomes the y, so it's a rotation on y's. No, it's a flip on y is equal to x, the equation y is equal to x. So I just need to know what this first thing looks like. So 4 minus 1 minus x over 2 squared. It's a parabola, it's been stretched by 2. I'm just gonna look it up, I don't care anymore. No, can't look it up, don't look it up, don't look it up. I don't want spoiler glitchless run. X over 2 minus 1 all squared. So x minus 1 would be moved to the right. Oh, let's think about a point. So if I substitute 0 into that, I get 1 in return. If I substitute 2 into that, I get 0 in return. So 0 gives me 1. 1 gives me half. 0. Okay, what does 3 give me? 3 gives me negative. What? Okay, let me think about this again. So 0 would give me... Oh, well, I've got to do the whole thing. Duh. Okay. So 0 gives me 4 minus 1 squared. So 3. So 0 gives me 3. What is 1? Okay, we'll go 2. 2 is the next easy one. So 2. 2 would give me 0. No, sorry, 1. So 0 squared, so it's 4. So give me a value there. Now let's try the next number. The next easy number to work with would probably be 4. So substitute 4 into there, so we get... So what would happen if I put 4 into there? So 4 over 2. So 4 over 2 is... 4 over 2 is 2. 1 minus 2, so negative 1, so it's 1. So 4 take away 1 is 3. Ow. Ow, ow, ow. So that means I tried... Yeah, okay, so it's an upside down parabola. Right, I think. Well, let's try 6. And negative 2. Try negative 2 first. Negative 2 is a bit easier. So negative 2 over 2 is 1, so it's squared, it's 1, so it's 0. Yeah. And I suspect 6 will probably give me 0 as well. So 6, which is 3, so 1 minus 3 is negative 2, yeah, that's 0. Okay, so it's an upside down parabola that looks like this. Okay. Now for the inverse, we'll take this line here, okay. And all of our x's becomes our y's. So 2, 4 would become 4, 2. Okay, 0, 3 would become 3, 0. 0, 6 would become 6, 0. 0, 6 becomes 6, 0. And negative 2, so that's down here. So negative 2, 0. Got 0, got that. And we've got 4, 3, so that becomes 3, 4. And we get this relation, which has been reflected. Like that. Right, there we go. So that's the equation. So the black one, so this is part 3, and the black part is part 1. Cool, we're on to question 13 now. A 2-meter high sculpture is made out of concrete. The sculpture is to be made out of concrete. The sculpture is formed by rotating the region around this, and this. Around the y-axis. So this would be y is equal to 2. So let me have a think. So here's my... Okay. This line, like, probably that goes through the center is y is equal to 2. This bit here should be more like this. So y is equal to 2 is that? No. That. So without this one here. Okay. That looks a bit better. So y is equal to 2, we've got y is equal to 0 here. We've got this parabola here, which is y is equal to x, and we've got this parabola here, which is y is equal to x squared, and this one, which is y is equal to x squared plus 1. Find the volume of the concrete needed to make the sculpture. Okay, so it is a volume problem. Volume problem. So question 13, part A. Okay, so let me draw just like a little of what's happening. So we've got this guy, we've got this guy, and we've got this guy. Okay, and we're rotating it around the y-axis, so around this way. Okay, so that's just rotating around the y-axis. Okay, so our equations are y is equal to x squared and y is equal to x squared plus 1. Now I think I want these in terms of x because I think rotating around the y-axis, so normally when we rotate around the x-axis, that's dx. So when we're rotating around the y, that's our dy, that's our changing y variables. So I think in this case, so volume is equal to pi. Let me get the formula sheet up because I'm pretty sure it's on there, just so I'm not getting lost. Hello volume, are you here? No, it's not. So the volume formulas are on the formula sheet. I'm just going to remember to get this the right way around then. Okay, so if these are the x's, so let me think about it in this general sense then. So y is equal to 2, y is equal to 0. So it's from 0 to 2. And it's this big one, take away the small one. Okay, so it's going to be y is equal to x squared, so x is equal to root y minus root y minus 1 dy. Okay, so add 1 to the power, divide by new power. So 2 on 3, 1 to the 3 on 2, minus, okay, so divide by the derivative, so derivative is just 1, that's fine, and then add 1 to the power, divide by the new power, so 2 over 3, y minus 1 to the power of 3 on 2. We're going from 0 to 2. Okay, so 0 cancels out with that side. So 2 on 3, so this is still pi times this stuff. It's going to be 2 to the power of 3 on 2 minus 2 on 3. 2 minus 1 to the power of 3 on 2, which is just 1. Minus, okay, and this is still being included in the calculation. guy still on the outside. It's going to be 0 minus 2 on 3, lots of negative 1 to 3 on 2. And that's from, yeah, like that. That's all. Okay, so let's calculate this and put down an answer and be done with it. So 2 on 3. 2 on 3 times 2 to the power of 3 on 2 minus 2 on 3. What do I want it to, by the way? Just the volume, so it doesn't actually say. So that's 1, 2 on 3. Well, that's just going to be 1. Minus, well, it's going to be plus actually, plus 2 on 3. I might do this a bit properly because I'm not sure what it is after all of the calculations. Plus 3 on 2. Math error, cool. So it's giving me, because I've got the square root of negative 1, don't I? Okay, so what the hell have I done wrong? Oh, I don't want to go through this and check it. No, don't care. We've tried. We failed. We had an attempt. When an object is projected from a point h meters, do not prove this person sitting in an empty room 3 meters high. The region enclosed by when an object is projected from a point h meters above the origin with initial speed v meters per second at an angle of theta, and the horizontal displacement vector is t seconds. You know what? What about 3 pages ago? 4 pages, 3.5. I don't remember any of this stuff, to be honest. A person standing in an empty room with 3 meter high ball throws the ball far above the room. Ball leaves the hand 1 meter above the floor and 10 meters from the far wall. The initial velocity of a ball is 12 meters per second and an angle of 30 degrees to the horizontal. Show that the ball will not hit the ceiling of the room, but it will hit the far wall without hitting the floor. 12 meters per second at an angle of 30 degrees. Oh, they're telling you what the vector is without having to show all the working out. Okay, that's cool. Person standing in an empty room which is 3 meter high. Okay, so 3 meters. So let's draw this room. 3 meters from here to here. He throws it from 1 meter high. Something like this, I'm guessing. So it will not hit the Okay, so if I substitute them into that, I think, okay, so what's this B? Okay, so it's 3 meters high, so I just have to show that the vertical component, oh, hang on, J. So the vertical component, I don't know how to spell vertical. So the vertical component, I think it's below vertical. Yeah, that's better. The vertical component, so is minus 5t squared plus vt sine theta plus h, where h is the point of the origin above. So 1 meter above is equal to our h. My velocity at the starting point, my theta at the starting point is 30 degrees. My velocity is 12 meters per second. And my time, show me that the ball will not hit. And we want to show you essentially this is less than 3. And 10 meters from the far wall. Okay, so we need to show how long it takes to get across here. So how long does it take to get across to the 10 meters? So horizontal, let's look at the horizontal for a second. So that's the VT cos theta. Okay, and if we work out how long it takes to get across, okay. So it's 10 meters is the maximum. So 10 is equal to V, which is 12t cos theta. So cos of 30 degrees. So 10 on 12 cos 30 degrees is equal to t. So the time it takes to get across to that side. Okay. Keep it precise. Okay, so what we just need to show now is that this guy up here at t, so at t is equal to 5 root 3 on 9 is less than 3 meters high. So minus 5t squared plus, well, we can substitute that in, I guess. 5 root 3 on 9 squared plus v, which is 12 times 5 root 3 on 9 sine 30 degrees plus 1. And we're going to show that this 3 meters is greater than that. Okay, so let's call shift store to A. Okay, so we've got minus 5 lots of A squared plus 12 lots of A sine 30 degrees, that's in degrees, plus 1. And it's 2.14, yep, 2.14, which is less than 3 meters. So therefore won't hit the roof in its motion. Cool. Cool, that was it, okay. The region enclosed by y is equal to 2 minus x. Okay, well, absolute value of x, so that goes there. And that is shaded in the diagram. Find the exact value of the area in the shaded region. Okay, well, I'm going to do this in halves, I guess. So half the first, half the second. So this is C. So we're going to do the first half first. And then the second half second. So 1 and then 2. It's between -2 and 2. Goes down to -1. We don't particularly care about those values, I don't think. Although, find the exact value of the area. Okay, so absolute value from -2 to 0 of, and it's just the difference between the two, isn't it? So it's going to be 2. Okay, so this is the positive one, so 2 plus x. Yep. 2 plus x minus 1 plus 8 over 4 plus x squared. Plus, and then the absolute value, the same thing, but from the other side, with one major difference, minor difference, it's going to be 2 minus x. Minus 1 plus 8. Because it's 1 minus 8, and so the minus just changes that whole thing. Okay, so that's area. Area is equal to this. Okay, so integrating this, we get 2x plus x squared on 2 minus x plus 8. This is 8 lot of, so we can rewrite this as 8 lots of 1 on 4 plus x squared. Okay, so integrating 4 plus x squared, we did this before, I believe. So 4 plus x squared. No, we did the square root of that before. This time, it's going to be 1 on a, which is 2 tan inverse of the function of x over 2, like that. So substitute some values in. So we're going to start with 0 plus 0 minus 0 plus 4 lots of 10 -1 of 0. Okay, minus, this is the first bit. So it's going to be -4, and this is all the absolute value of -4 plus 2. So minus 2 squared is 4, 4 divided by 2 is 2, plus 2, plus 4, 10, -2. Doesn't need to leave this in exact form, does it? Show the exact value. Okay, we're just going to leave it in terms of 10. Plus, okay, now we do the other side, so it's going to be 4 minus 2 minus 2 plus 4 tan inverse of 1. Hang on. That should be -1, not -2. Okay, that makes me feel so much better. So these are going to disappear anyway. So minus 0 plus 0 or minus 0. So that disappears as well. Plus 4 tan inverse for 0. Okay, so the tan inverse of 0 is 0, cool. So that cancels out, and that cancels out. So we just got 4 tan of negative 1. So 4 tan inverse of negative 1 plus 4 tan inverse of 1. And it's the absolute values of these guys. You've got to remember too. Always the absolute values because it's an area. So tan negative 1 is equal to, so it's negative pi on 4. So it's going to be 4 times negative pi on 4 plus 4 times pi on 4. So that cancels with that, negative makes positive, so pi plus same with this, pi, which is equal to 2 pi. And so that's the exact value, the exact area. Yuck, that was gross. Okay, last one for this question. The numbers a, b, c are related by the equation a is equal to b minus d and c is equal to b plus d, where d is a constant. Show that this is equal to tan b. Okay, so we've got a is equal to b minus d, we've got c is equal to b plus d. I'm going to show that sine a plus sine c over cos a plus cos b c is equal to tan of b. Okay, so let's relate these two equations back to each other. If we were to add these together, we would get a plus c is equal to 2b. Okay, it doesn't really help us. And we could also get a minus c is equal to 2d, or negative 2d. It's actually c minus a is equal to 2d. Or d is equal to c minus a. So we probably want them in relation of b's, I'm thinking. So a plus c is equal to 2b. Or not 2b. Let me try something. Actually, we don't have to do that just yet. So, no, well, they just add together, don't they? Yeah, that doesn't really do anything for me. Doesn't really do anything for me. The sum of two sines being equal to something. Numbers a, b, and c are related by the equations a is equal to b minus d and c is equal to b plus d. Oh, of course, okay. So what we're going to do, we don't need these guys over here. What we're going to do, we're going to go sine of b minus d plus sine of b plus d cos of b minus d plus cos of b plus d, like that. I'm going to look at how this is related. So, using a formula sheet, sine of b minus d, so we go sine b cos negative d plus cos b sine negative d plus, and the same thing, so sine b cos d plus sine d, or cos d sine. And because we don't need equals just yet, we're going to do the bottom line as well. So for cos, it's going to be cos A, cos B. So cos B cos negative d plus sine b sine negative d plus sine, or cos b cos b cos d plus sine b sine d. Now, sine is an even function. No, sine is odd, cos is an even function. Yeah, cos is an even function. So because cos is even, cos of negative d is going to be equal to cos of d. Okay. And sine is odd, negative sine of d is going to be equal to sine of negative d, which is really important. Because what it allows us to do is it allows us to change some of these. So cos, so this is going to become sine b cos d. Probably don't need the brackets now. Sine b cos d plus, okay, now sine flips it, so it's going to be negative cos b sine d. Okay, plus sine b cos d plus cos b sine d. And so that cancels out with that. Okay, now same for the bottom line. Now cos b cos d, so cos is the one that goes even, so it's going to be cos b cos d plus, okay, so this comes minus sine b sine d plus cos b cos d sine b sine d. Okay, so sines cancel out in this one. So we're left with 2 sine b cos d over 2 cos b cos d. There's a much shorter way to go around that. Lol. Oh well. Oh, of course. Cancels, and we're left with sine b over cos b, which is equal to tan b. So let's look at the body equation. And that's it. Okay. So that's part 1 done. It's a 2-parter. So hence or otherwise solve this, and I'll write it down as well. So we're going to solve sine of 5 theta on 7 plus sine of 6 theta on 7 over cos of 5 theta on 7 plus cos of 6 theta on 7, which is equal to root 3. Okay, so we know that this is equal to... Okay, we need to work out what that middle guy is, what that value is. So tan of b. So b, we can just use those simultaneous equations. A plus d. Okay, and this is where we solve these guys for b. So a plus d is equal to b. C minus d is equal to b. A plus d equals C minus d. A minus c is equal to minus 2d. Oh, I've got it here. A plus c is equal to 2b. So a plus b, c is equal to 2b. Okay, so 5 theta on 7 plus 6 theta on 7 equals 2b. So 6, 7, 8, 9, 10, 11. So it's 11 theta on 7 equals 2b. So b is equal to 11 theta on 14. Okay, so we're looking for when 11 theta on 14 is equal to that. So when's tan equal to root 3? What values? So 11 theta on 14 is equal to, so tan, do we have a domain for this between 0 and 2 pi? So there's going to be 2 solutions. So root 3, back to my formula sheet. Root 3 on 1, so it's 60, so it's pi on 3. And 11 theta on 14 is going to be... Oh, let me write down the solutions. So pi on 3, so it's going to be 2 pi plus pi on 3, so 6, 7 pi, no. Yeah, 7 pi on 3? What's in the middle though? So all stations 2. So it's going to be pi plus pi on 3, which is 4 pi on 3. Plus 7 plus 10 pi on 3. Plus, what comes after 10? We're just adding 3 on, so 13 pi on 3, and then 16 pi on 3, and etc, etc. So, we'll start with the first one. 11 theta equals 14 pi on 3, and so theta is equal to 14 pi on 33. Okay, That's one. The second one, 11 theta on 14 equals 4 pi on 3. So 4 times 14 is 14, 21, sorry, 14, 28. 28 times 2 is 56. So 11 theta is equal to 56 pi on 3, and so theta is equal to 56 pi on 33. And I think it's going to be all the solutions, I suspect. So theta is equal to 14 pi on 33, and theta is equal to 56 pi on 33 as well. Okay, that actually wasn't as bad as I thought it was going to be. Alright, let's get stuck into this last question. Feeling good now. Got on a roll. I feel like I'm about to get absolutely destroyed. Okay, plane needs a travel distance that is on a bearing of 63 degrees. The engine is set to fly at a constant 175 kilometers per hour. How does it mean south? On what constant bearing to nearest degree should the direction of the plane be set in order to reach its destination? Okay, so question. Seems like a third of it almost. So 62 degrees. Oh, it's 63 anyway. That's alright. Okay, 63 degrees. The engine is set to fly at a constant 175 kilometers per hour. So it's traveling at 175 kilometers per hour. However, there is a wind from the south with a constant speed of 42. So 42 kilometers per hour. It's traveling up. On what bearing to nearest degree should the direction of the plane be set in order to reach this destination? So, I can't believe there's still 2 pages left actually. Plane needs a travel distance 63 degrees. The engine is set to fly at a constant 175 kilometers per hour. However, there is a wind from the south at a constant speed at 42 kilometers per hour. On what constant bearing to the nearest degree should the direction of the plane be set in order to reach its destination? Oh, I wouldn't even know how to attempt that. The bearing is 63 degrees. So it's traveling this way. It's been constantly pushing up, so it needs to come down. So what's the difference it needs to be? Well, let's call the distance traveled x. Okay, the distance traveled is x. That's our distance traveled. Or we could call it d, so I remember what it is. So distance traveled is d. Now, the plane is traveling 175 kilometers per hour at an angle of, so it's 63 that way, so it's going to be 27 degrees this way. Pushing it up, so it needs to adjust, so it needs to come down to make adjustment for that. So how do I get the adjustment in? How do I get the adjustment factor? I've actually got no idea how to even attempt this, to be honest. I'm actually just going to skip this, I think, for now, and I'll try and come back to it. But I don't think I can. I think I'm going to have to use all my skips there. So what's that? I've skipped 3. I attempted that. Attempted all those. Attempted all those. 3. Attempted that. Didn't attempt 7, so that's 4 marks. So 5 marks I haven't attempted. So I've got 5 marks up my sleeve if I skip that one. Alright. Which I'm going to do because I don't understand it, to be honest. Anyway, in a certain country, the population of deer was estimated in 1980 to be 150,000. The population growth is given by the logistic equation dp to t is equal to 0.1p. C minus p, where c is the carrying capacity over c, where t is the number of years after 1980. In the year 2000, the population of deer was estimated to be 600,000. Use the fact that this to show the carrying capacity, that the carrying capacity is approximately 1,130,000. Okay, so dp dt here it is. Certain country, the population of deer is estimated in 1980 to be 150,000. The population growth is given by the logistic equation dp over dt. dp dt is equal to 0.1p over c. In the year 2000, the population of deer was estimated to be 600,000. Use the fact that the carrying capacity is approximately 1. So the carrying capacity, what would that equate to? The maximum amount? So the maximum population? So we'd be looking for P when P is the maximum? I don't know how to attempt this one either. The population growth is given by the logistic equation dp to d is equal to this. So this is the derivative. In the year 2000, the population of deer was estimated to be this. So I'll just write some stuff down, get it in. So at t is 20, p is equal to 600,000. So t is 20, p is 600,000. At t is 0, the population was 150. And the maximum population is 1.1 million. Okay. It's a 4 marker, so it's going to be a lot to do. Let's just skip it and come back. I don't know. Okay. Vector sheet V show the thing is this. So V, so let V be equal to AI plus BJ. So dot product then is equal to A times a plus b times b, which is equal to a squared plus b squared. Now, v squared, so the modulus, it's just the distance, I believe. So it's going to be, so b squared, so a squared plus b squared. Well, it's just the distance, it's not actually a modulus. Oops. Cool. That's the easy part. Okay, part 2. Part 2. In the trapezium ABCD, BC is parallel, AD is to AD, so BC, that and that parallel, and AC is equal to BD, so AC is equal to bloody oath it's not. Let AB equal to AB. So A, B, and AD equal KBC. Yeah, that makes sense, it's just a constant. Using part I or otherwise showed it 2A dot B. Okay, so 2 times A, 2 times vector A dot B plus 1 minus K of B squared is equal to 0. Okay, so I'm going to start off with A. So 2 lots of A. Do we even have numbers? No, we don't. Okay, well that's cool. Cool, okay. If AC is equal to BD, then it's got a, that's not a good picture for that. That's a horrible picture. So AB must be equal to CD. AC is equal to BD. Let A be equal to the length AB, B equal to the length BC. So 2A dot B. Oh well, let's just make it generalized. Let's let A be equal to x1i plus y1j. B be equal to x2i plus y2j. Okay, so then 2a is going to be equal to 2x1i plus 2y1j. And then dot product that with this is going to give us so 2x1 x2 plus 2y1 y2. Now b squared b squared is equal to b dot b, which is equal to so 2x, no, it's x2 squared plus y2 squared. Okay. And we're going to do 1 minus k, what's of that? Okay, so how's y1 and y2 related? KBC. So BC and AD related. BC and AD are related. AB, BC, and AD is equal to KBC. Oh, let's just try to throw out a Logarithm and see what happens. So 2a, and if it doesn't work, I'll just move on. Plus 1 minus k, x squared 2, plus y squared 2. Oh, I should have the other version, shouldn't I? So 2x1, x2, plus 2y1, y2, plus 1 Now, my thought is BC. Okay, well AD is equal to KB. AD is equal to KB. So if we know what K was, we could substitute it straight in. Or if we knew what AD was. Okay, get rid of this. We don't need this just yet. Okay, so don't even need this line. It's just this line here. So 2a dot b plus 1 minus k lot of b squared. Okay, this is the same as 2a dot b plus, okay, so 1 minus k lot of b dot b. Okay, now 2a dot b plus b dot b minus k lots of b dot b. That still doesn't help, because I don't know how AD relates to the rest of it. Alright, I'm giving up. I've attempted. I'm moving on. Question D. Oh, for Christ's sakes. What are these ones? Alright, a certain factorial proportion of faulty items reduced by a machine is p is equal to 3 on 500, which is considered to be acceptable to confirm the machine is working. To the standard, the sample size of n is taken, the same proportion p is calculated. It is assumed that p hat is approximately normally distributed with u is equal to p and sigma squared is equal to that. Factory machine will be shut down if it's greater than 4 on 500. The sample size is chosen and the chance of shutting down the machine unnecessarily is less than 2.5%. Find the approximate sample size giving your answer to the nearest. Oh, don't know how to do this one either. Funny that. I tell you what, I think I might just call it there. I have had a really big day and I'm actually over it. It's been 7, almost 8 hours of maths in one go. I've just had enough. I've honestly just had enough. My throat is killing me. I'm starting to stink. I'm just ready for the end. So I think I might just call it there because I don't think I'm going to get this done. Otherwise, the last few questions are just... It's... If you haven't done maths in a while... and... you also... you know, like, actively studying it... it's just going to be too hard. It's going to be hard. Remembering all that sort of stuff. It's why... whenever teachers tell you... go over your material often and often and often so that stuff sticks in your head. Not like what I do. And forget most of it. Although with that being said, I think it's a pretty good effort, especially considering how much time I have wasted, more or less. Alright, so with that being said, thank you for those who tuned in tonight. As I said, I'm so done. And this is definitely a one-off thing. I'm never going to do this again. I can assure you of that. Alright, with that being said, I want you guys to take care, look after yourself, and I'll talk to you in the probably next year, if you're watching in year 11 or whatever. Take care.